Alrighty, I think we're almost there. Just seeing the stream kick in now. Brilliant. Looks like we're up and we're live. Fantastic. Just give it a second to make sure the bandwidth kicks in. There we are. Brilliant. Fantastic. Right. Thank you all very much. Sorry for that momentary technical issue there, but hopefully that will be, I'm not even going to say it. So we'll carry on from here. Thank you all for attending. This is the welcome address for ADCx Gather 2025. My name's Jim Roper. I am going to be your host throughout the event to introduce our wonderful array of speakers. And I am here to just give you a quick overview of how the event's going to work, make sure you've all got into the right places and you know how things are going to work for the rest of the event. So I'll be relatively quick, just going to go over some of the broader aspects. If you're joining us from YouTube, just be aware that we have quite a lot of content happening in our virtual venue and also in Discord. If you haven't pre-registered, you won't be able to access that content, but we do have a late registration form, which we're going to be posting to the YouTube feed. We'll be doing that in just a moment. And then you'll be able to sign up through that. There'll be points throughout the day where we're going to import the new users and then we'll let you into the venue. So if you sign up to that form, you'll see the different times that you'll be able to then enter from. So we're going to post that in just a moment into the chat. But otherwise, I'm going to just quickly share my screen with you and show you the Discord server. So if you are registered to attend, you need to click the link we sent you in the onboarding email. And then when you join the server, it will look like this. So what you'll want to do is go to the verification channel here, and you're going to type the command !verify. When you type that in and you hit enter, you'll get a message in the top left corner of your Discord interface from the Discord verification bot. Put the same email address that you registered with on the form into that as a response, submit it, and at that point the bot will give you the permissions to access the rest of the server. Once you do that, the server will look like, let me just find the correct one, here we go. Server will then look like this for you, and you'll see all of these extra channels on the left here. You'll find that there's some information channels at the top. There's the session discussion channels for text-based chat of the sessions, and then there's a help desk where you can post questions or issues that you're having and get live support from one of our very helpful volunteers. Otherwise, we have our Gather venue. So if you haven't joined us in Gather already, this is our Gather space. So just see that there. Let me just check I've got my correct settings on. I do. So when you get into Gather, you'll come through our onboarding room. Do take a moment to look at the bits and pieces in there. Quite a lot of information. And it gives you a nice overview of how the whole system works, some of the different objects that we have in the space. Once you get in, you can customize your character just here, so you can set your name, customize your character to look like yourself, so you have a nice virtual representation of your same self-identity in the virtual venue. And then when you get in, you can move around with your arrow keys. This uses a proximity-based video chat system, so do keep your webcams and microphones on where you can. It creates a much more engaging experience for everybody. But as you move around, as you get closer to others, you'll be able to see and hear them, and they'll be able to see and hear you. You'll also find there's dedicated conversation areas, like this group conversation space here. You can see it's highlighted lighter color, and the darker area is around the outside. Anyone in this space with me can chat with me, and anyone outside can't hear into the space. So nice ways to kind of have group-based conversations that are kind of a bit more private or without being interrupted. While you're wandering around, you'll be on the proximity system, so you can kind of bump into people and have those organic interactions. Otherwise, to access the talks from Gather, you can get to everything from Gather. So this is the main kind of hub for the event this time. To access the talks, you come into the main auditorium, take a seat in any of the chairs available, hit the X key on your keyboard, and it will open up the link to the stream. Sorry, I need to move to an actual chair. There we go, hit the X key, and you can click the link, and it will open the Zoom stream. Anytime we have talks happening, please come into the auditorium to access them. Otherwise, there's additional content happening out in the wider virtual venue. If you hit the calendar button in the bottom right-hand corner, you'll find all of the listed content in here. You'll get a little notification before anything's about to start, and a button will appear that says, "Take me there," and you can click that, and it will walk your character to wherever that event is taking place. Otherwise, the rest of the controls are pretty intuitive. You should be able to find most of the things as they are, but I'll just point out the participants panel is here. If you want to find someone, you can right click on them and you can actually do locate or follow, and it will walk your character to wherever that person is. But otherwise, do take a look around our virtual venue. We have a lot of content in here. We've got our various community partners who are all in various buildings around the space that you're welcome to go and visit. We have our poster building in the middle, which is where we're going to host our poster sessions. And again, this content is exclusive to the virtual venue. And then we're going to have our quiz at the end of the day in the Chuck boat. Brilliant. I think that's just about everything that you need to know in order to engage with the event fully. And now I'm going to hand over to Bobby and the rest of the ADC team to take you through some final bits while we get the first speaker set up and ready to go at the top of the hour. So thank you very much. I'm going to stop sharing now. I'll hand over to Bobby.
Well, thank you, Jim. Yeah, appreciate it. And hello, everyone. You've got members of the ADC team here today, and Jim included, of course, but we've got Tom Poole, Prashant Mishra, and Derek Heimlich, and we are here representing ADC team. Hope this is interactive. If you have questions, we might be able to take some questions too if we have time. I think I'm just going to jump right into it. I shared a few slides here with you. Let's see. Let's just kick off and we'll go from there. So welcome to ADCx Gather. This is great. If you are joining us on YouTube and you want to get involved with the virtual venue, please do sign up for that, the late sign up form that Jim was mentioning, and get up on Discord and join us in the virtual venue, because a lot of what's going on today, especially the meetups, are something you're going to want to check out. The poster sessions you'll want to check out. Those you will not be able to see on the YouTube stream. The stream was going to be carrying the talks. So if you want to see all the additional content and the networking, you got to get on the virtual platform. Big shout out to the sponsors. So these are sponsors for ADC 25, and this event is part of ADC 25. We consider this to be a preview event for the larger event that's happening in November, but thank you to our sponsors. Without them, none of this happens. We do run this as a not-for-profit event throughout the year, and their sponsorships allow these pop-ups to happen. So very excited about that. Special shout out to our diversity sponsors. We do have diversity scholarships for the ADC in-person event in Bristol. So if you are interested in our diversity outreach, please go to audio.dev and check out what we have there. A very special shout out to Acoustics, that not only, so these companies that you're seeing here do help us with scholarships for people to attend the in-person event, and Acoustics has gone the extra mile of covering the hotels and lodging for the event, so for up to 10 recipients of scholarships. So I think that's just phenomenal of the dedication these companies have shown to helping us with ADC. So make sure you, if you're in the Gather space, go around, check things out. Certainly join us for the pub quiz later. That's, I believe, on one of the boats in the docks. Poster sessions, all the above. If you're on YouTube again, sign up for that late sign up and get access to Gather. But why are we here? So what is this all about? ADCX Gather, really, we want to get you a teaser of what the actual Audio Developer Conference is about. The Audio Developer Conference is a paid conference, so there are fees for accessing it online, and ADCX Gather was created as a way to show everyone what the online experience looks like and what the virtual venue looks like in a free event. So for those of you that are in Gather right now, you are taking a look at basically what our Audio Developer Conference virtual experience looks like. So you're getting a feel for what the presentation rooms look like, what the poster room looks like, what the meetup rooms look like. You're getting an idea of what that venue is before the actual event is here. So hoping you get inspired and you like what you see and you consider joining us for the Audio Developer Conference that happens later in November. So there'll be some adverts for that throughout the day. Let's see. So here's the event coming up in Bristol. It's November 10th through the 12th. So it's going to be similar to today, but think of it as a 3-day event with talks each day, workshops, and as you can see, over 80 speakers, exhibits. Certainly something to check out if you are happy with what you see today, and we'd love to have you join us. We're not just a conference, though. Just like this pop-up, there are pop-ups around the world. And if you are interested in hosting a pop-up, reach out to us at info@audio.dev, and we'd love to speak to you. And we have other events like the mentorship program. And we do have Derek here who can say a little bit about the mentorship program. If you want, Derek, I think give a little advert.
Sure. Yeah, thank you, Bobby. Hi, everyone. So the ADC mentorship program, I'll keep it short and sweet. We pair up mentors, people who are experienced and have been in the community, the audio software community for quite a while, with mentees who are just coming into the community or perhaps, shifting, doing a career change. And it's a once a year kind of program. It's fantastic. If you want to know more about it, we're already kind of in the middle of it at this point right now, so there's no signups. But if you want to know more about it, please go to audio.dev and sign up for the newsletter because that will be the best way to keep in touch about what's happening and when the next mentorship session is going to be. Thank you.
Thank you, Derek. It's a great program. Yeah, so please join us. And if you can help us as a mentee, we would love more mentees or mentors as well. We have Prashant on the call. So on this webinar. So Prashant heads up our ADCX India initiative. Would you like to tell us a little bit about what's going on there, Prashant?
Yes, sure. Hi, everyone. My name is Prashant. So ADCX India is basically a shorter pop-up event of ADC happening hosted in India. So we did the first event in 2024, and that was about setting the foundation, letting everybody in India who is into audio tech or music tech to know that there are other people here as well who are interested. And then this year was the second version, ADCX India 25, and that was all about maintaining the momentum. And we are in plans for ADCX India for the next year as well. So if you want to know more about that, sign up to the newsletter so that you get notified. And we'll most likely inform the dates at the main ADC 25 event in November. So that's how you'll get to know. Within the Gather environment, there is also an ADCX India booth. It's under the name of Urban Tandoor. So definitely show up there and we can hang out and discuss more ideas. But yeah, if you're excited, if you are in India and you're excited to attend the event, stay signed up and we'll come up with more news soon. Back to you, Bobby.
Thanks, Prashant. Yeah, looking forward to ADCX India for sure. And I think it's in the January timeframe next year in 2026. And we do have some, I hope we can share the news probably in November as the dates come together, but there'll be an ADCX in Copenhagen in April next year as well. So we're excited to launch that also. How do you get to learn about all these events? Please head over to all of our social channels. We've added a few since then too. We're on Mastodon and Blue Sky as well. But everything's at Audio DevCon. Certainly head over there. We do post information on call for papers and these events as they come up. Also look at if you're joining us on YouTube, you're already there. But if you're not aware, our Audio DevCon channel on YouTube has all of the recorded talks from all the previous years. So we are in our 10th year of the Audio Developer Conference. So the 10th anniversary event is coming up in Bristol. And all these lovely videos are up there for access. So please check them out. And we did cross the 500 video mark. So that's brilliant. Um, Big news to announce. We will be announcing ADCX, not ADCX, sorry, ADC Tokyo, a 3-day event in June of next year. So you'll hear more about this, but I wanted to share this first because you are the first audience to see this announcement. So I think this is very exciting. We will be over in Akihabara in the beautiful UDX event center. So we're taking over what they call Akiba Square and 3 rooms in that space. We'll have 3 stages and networking events and sponsors, mostly from the Japan area. So very excited by this event and hope you'll join us. This will be a in-person live event with the streaming feed as well. Let's see. We're running out of time. So most important, if you are interested in anything what we shared with you today, I would say please sign up for the newsletter. We try not to spam everyone, but we do include important information, things like when tickets go on sale, when early bird tickets are available, announcing new events. and certainly things like call for papers and call for talk reviews. So please join the ADC newsletter. You can just go to audio.dev and you'll see a link there for signing up for the newsletter. So I think that would be a great way to stay in touch. So that's all I had, and I know we're about to go live with our first speaker. Tom hasn't spoken. Tom is the head of Juice and joining us as a very important team member for ADC. I think you'll be meeting with Tom for closing remarks today, but Tom, any parting words before we kick into our first speaker?
Just to reiterate something that Bobby said is that if you are just watching the stream via YouTube, you really are missing out on a lot. There's poster sessions, there's meetups from our community partners, there's a quiz, there's a treasure hunt. That's where all the networking's happening. So really do dive in and give it a go.
Yeah, thank you, Tom. That's a really good point. And something I didn't mention is another thing that's happening inside of Gather is that we've got these really great meetups going on, and those will be happening at 1600 UTC. We've got 3 meetups today. One is the Interactive Audio Special Interest Group, having a chat about the shaping the future of interactive audio. We also have an Immersive Audio Network meetup going on at 1600. And we also have a lovely accessibility in audio meetup being hosted by Jay Pocknell. So 3 amazing meetups to go check out. So please try to get on the virtual venue if you can. And then posters, lots of wonderful academic posters to come see and talk to the poster authors. Okay, we're ready to jump into our first talk. So thank you for joining us, and we'll see you again at the wrap up after the talks are done. I'm very proud to introduce our first speaker is Skizzy, and Skizzy's going to take us through the topic of minimalistic music composition with C++. So thank you.
So yeah, hi everyone. I'm speaking from Hyderabad, India, and welcome to ADCx Gather 2025. I'm very excited to present my talk here. And so I will mostly be covering C++, and how you can write just small amounts of code to make music with C++. So just a bit about me. So you probably know me as Kizzy on the Discord, and I try to, keep discussing some stuff related to any of the topics like AI or anything on the Discord channel usually. And these days, I'm mostly trying to build apps for artists. I'm trying to build some games. I'm trying to do some VR apps as well. And so, yep, you can always ping me on Discord if you need anything. So just to give you a brief idea, so right now I think we are basically doing neural music, you could say. So a lot of AI music that is being generated. But if we go back to the start, it's sort of like the exact opposite. We had some sound chips, and in the sound chips, you used to program them via assembly, and you used to ping them instruction by instruction, and it was all 100% deterministic, and there was no way in which you could, have something guesswork there. It's always like 100%. And so from there to DOS and evolution like MIDI, and we right now have the AI thing on us. So why C++? So my main motivation was to kind of explore the low-level side of things, and and that's where C++ usually shines. And you have things like an accurate timer. There's no GC, and you have many libraries that you can use, and that's basically where I got started with C++. Now it is audio development is a kind of a challenging thing. So you can start with just little amounts of code, and that's hopefully what you can get away from my talk. So here's a first example. So this is the simplest thing you could perhaps do. I am basically using this library called miniaudio.h, and it's a single header library, so it's very easy to get started in your projects. And you can just simply load a 909 wave. You can load a snare. I've started a small timer, and I'm just increasing the tick count, and then I'm able to play the 4-on-4 kick, and then I'm able to align the snares as well. So this is basically the most simplest thing you could do today, to just make some simple sounds with C++. So when it comes to timing, the time is sort of the most important thing that the CPU does. And right now, when in any you're using Windows or Mac, your operating system is fundamentally managing dozens of applications. And that's the same for your DAW as well. Your DAW is managing dozens of instruments and effects. And at the heart of it is the clock, where you basically measure time with respect to the CPU. Uh, Audio developers typically rely on the uh, timer. So you can think of it like the sound card has a sampling rate of 48,000 samples per second, which roughly translates to 21.33 milliseconds. And your sound card is pushing the audio data at this speed. And this is usually the way your DAW is perhaps tracking time. MIDI hardware devices have their own frequency with which they run. And so usually they go at a BPM, and at a finer level, they again go down to a finer resolution than that, ranging from like 960 to 40, 24. 24 is probably the least common resolution that most hardware devices probably support. And so here is a basic timer. Again, this is if you're coming from the JavaScript world or the Python world, this should be fairly straightforward. My main background was preliminary in those languages, so this is the first thing I got started with. And this is not optimized, and but it still goes still goes far because it is C++ and things are in general fast. So coming to sequencing, we can, if you think of an orchestra, the conductor is effectively like a sequencer. He's kind of triggering each musician saying, okay, start your section and start the flute, start the violin. And when it comes to what the conductor is effectively doing is he's keeping the time, and he's also telling each section to either intensify their instrument or play it more slowly or gently fade out. So in many ways, this is what I mean by sequencing. Now, sound design is another beast altogether. In sound design, you can do many more complicated things. But when it comes to sequencing, it is fairly a straightforward process, but it's also easy to get started with. You can think of sequencing in terms of whether it is discrete, so where you're triggering things, whether it is continuous, you're increasing the intensity of an instrument slowly, whether it is periodic, which is sort of like a sine wave, which is operating at a very low frequency, like 20 hertz. Or you can think of a generic sequencer also, which I will show. So coming to MIDI, so you can probably uh, just 10, 20 lines of code, and using the port MIDI library, you can probably easily play a MIDI note. And this is something that you can use to talk to the DAW or the hardware. Coming to generic classes for sequencing. So at the very most basic, uh, basic sequencer that you can do is doing a random number generator. As I explained, there's a clock that is running, there's a timer that is running, and this timer continuously sends a tick message. at the rate of the BPM or, a much finer resolution than that. And you can program a simple class with a tick method to kind of run things. And random numbers is easy to get started with. And if you're going a bit further, you can probably use a Markov chain. Markov chain is you can think of it like a miniature neural network. And here you have more control because you can control all the weights. And because of this, the neural network is much more easily malleable. And the weights are very visible, and it's just an array of arrays. And you can use a standard C++ library to, you can use standard vector, standard discrete distribution to probably design a simple Markov chain. And now it need not just be a generator that is generating Markov sequences. It can also generate it can also generate the tick can listen to a network request and generate a new event, for example. When it comes to, speeding things up or slowing things down, the best way to do that is curves. And curves are also very easy to program. If you look at if you look at an easing curve, an ADSR, or an LFO, these are quite easy to get started with. The other, if you've used any hardware instrument, you might have seen there's a small user interface that they have. And these interfaces are quite easy to do. And on Windows, Mac, and Linux, you have this nice library called FTX UI that can do some of these interfaces. So I've done a drum pad and I've also done a sequencer. I can demo that in a while. Now, as I said, the timer that I've designed is not optimized. You can, if you're using something like Super Collider or you're using Chuck, they actually have a virtual threading that they do. And in modern C++, you can use coroutines to perhaps, you can use coroutines to emulate those. And there's some more libraries. So let me quickly show a small demo. I think hopefully, yeah. So I have a small DAW running on the background and I'm interacting with it using MIDI. And so I've designed a small machine pad of sorts, and I'm just going to trigger some samples. So yeah, hopefully this is just sequencing. I'm not doing sound design. I'm just triggering samples here. And these are standard loops that you have. And yeah, so there are many small libraries like these that you can perhaps use in your project. And if you're just using sequencing, just triggering things and drawing curves, these things are easy to get started with. And perhaps if C++ has been a bit scary to you before, hopefully I have showed you that with just a small piece of code, you can probably make interesting things with it. So yeah, I think you can find me at these links. So I think over to you guys. And I'll be available on Discord if you have any doubts.
Thanks, Giddy. Are you done now?
Yeah.
Brilliant. Thank you very much. That was fantastic. We really appreciate you being here. I'm going to send you back to the backstage. So thank you very much indeed. There we go. Brilliant. So we're now joined by Rutledge. I'm just bringing him into the webinar now. And just give me 1 second. There we go. Hey, Rutledge, do you want to just turn your camera on and say hi to the audience? There you are. Brilliant. Hello.
Hey, hi. Hello, everyone. How are you doing?
Brilliant. So you have a pre-recorded video, so we're just going to queue that up, but just wanted the audience to know you are here. So if you have any questions, post them in Discord, and you'll be able to respond live while the session is going. So thank you very much, and we're going to roll the video now. So I'll just cue that now.
Sure. Thank you very much.
Thank you very much. Just 1 second. I just need to. I've realised I've hit the wrong button there. Let me just give it 1 second. There we go. And now we're going to cue the video in. There we go.
Hello everyone. I hope you are having a good day. Thank you for joining in my talk. Today I want to discuss a gap in Linux audio stack, runtime audio codec switching. This might sound like a very niche problem, but in fact it's extremely important for automotive age devices, where power, latency and safety requirement means you can just fix one codec and forget about it. Why? Is because cars don't have one uniform audio workload. They have dozen, each with very different requirements. A quick introduction about me. I'm Ratwish Trivedi, the co-founder of Silicon Signals. Our team contributes to upstream projects like Linux, Zephyr, AOSP, and U-Boot. Over the years, I have worked on products across consumer electronics, healthcare, IoT, audio, video, and especially automotive. In all of this domain, audio pipelines have been a recurring challenge to us. In fact, in one of my automotive projects, where I encountered this runtime switching problem, we had a SOC running a high-quality infotainment audio, but at the same time, the hardware had to support an emergency e-call. We realized that either we wasted a lot of power or we risked safety compliance. That's what it motivated me to dig deeper into ALSA internals. Now let's look at why automotive is different. Take infotainment as an example. For music streaming or video playback, you want Opus high quality and high bitrate codec that might consume around 25 milliwatts of power, but it delivers expectation on the audio which passenger expects. But an emergency call at the same time, it requirement flips. You need something like G729, which is a low power and low latency, only about 5 milliwatts. It's not about quality anymore. It's about fast and reliable communication. If SOC always run on Opus, you are wasting precious energy. If it always runs on G729, you are sacrificing audio quality. Now clearly we want a runtime switching to move codecs seamlessly depending upon this situation. But we'll see that Linux doesn't allow us that. Here is how the Linux ALSA is currently available. From user space, you open a PCM device and call sound PCM hardware params. That request will travel through front-end handler into DPCM BDI hardware params and finally into sound SOC die hardware params. At this point, the codec driver programs the register and now the driver codec is fixed. If you need another codec, ALSA forces you to stop the current stream and reopen it. That means 100 millisecond of dropout and CPU spike. And in car, especially in emergency system, it's not acceptable at all. Of course, people have tried workarounds. Let me walk through them. User space transcoding. You decode in one codec, re-encode in another. That works but burns CPU cycle and drains a lot of battery. In vehicle with dozen of other real-time tasks, this is not suitable. Second is multiple ALSA devices. You expose multiple PCM device per codec. The problem is the choice is made at open time. There is still no runtime switch and application gets locked in. Third is restarting PCM stream. Yes, you achieve a switch, but only by tearing down reopening the stream. That gives 100 millisecond of gaps. Now imagine that is happening in the middle of an emergency call. The driver is talking to an emergency service. Completely not acceptable and it's unsafe. So none of these hacks are meeting the automotive grade requirements. So what would a real solution look like? I see 4 building blocks. This is a proposal from our side, an ALSA control interface. This exposes standard control where user space can request codec not just at stream time but in the mid of the stream. A power scheduler in the kernel, which is a decision making engine that takes into account battery, network, and safety priorities. Triple buffering in SOC drivers, so we call a shadow buffer. One codex will drain, another codex will start. And standard Linux device trees, so we can capture heats like power consumption and priority at standardized way across all the SOCs. These are not trivial, but at least realistic extension for what currently ALSA is doing. This is a code snippet. So now let's put it all together. On the left, we do have inputs like battery, network state, and safety priorities. Inside switch, there are 2 components we do have. One is scheduler, which decides when to switch, what to switch. The shadow buffer, which overlaps PCM frames, so one codex drains down while other starts. On the right side, we do have actual codecs. Opus for high quality, G729 for low power, and PCM for latency. The key point is the scheduler makes a decision and shadow buffer makes it seamless. This is how we move from 100 millisecond of gap down to sub-frame transitions. Here is how code might look like. In kernel, we define an enum that gives controls to user space to pick codec, and behind the function like scheduler codec switch, we triggers transition. A prepare function feeds shadow buffer, and at safe boundary we swap the DMA pointers. This is how a device tree might look like. We describe each codec with its power and priority. For example, power Opus will require 25 millivolts of power with 2 priority, and G729 for 5 millivolts with priority 1. So now these are not full implementation, but these are the sketches. ALSA could evolve on top of this in a structured and clean way. So what we can gain out of it? Dropout will reduce, like from 100 millisecond to 100 frame boundary, 10 to 20 milliseconds. Low CPU usage compared to transcoding or restart methods. Battery life, since now ecosystem of codecs have become intelligent. And importantly, we are achieving safety compliance as well, where reliability is critical. Now I'll be clear that these are not the actual projected number, these are just measured with the ALSA ground and buffer analysis. Of course, this is not an easy task, let's be honest. The problems are synchronization. You might align the exact frame boundaries, otherwise you risk click or loss samples. Codec state management, all these codecs will have their own context, and preserving those states will be during hot switch will be complex. Framework changes, ALSA and SOC PCM operations were never designed for this switch, so we'll need some kernel APIs and device trees. Fragmented SOC ecosystem. So Texas Instrument, NXP, Qualcomm, each has different DSP IPs. Getting consistency across all the vendor is tough. User space policies, system like Pipewire and Android Audio HAL needs to cooperate with these changes, otherwise kernel changes won't be useful for us. These are significant challenges. So what is a roadmap look like? First, we'll need a kernel prototype to validate the shadow buffer and switching logic. Then we extend codec topology to support in ALSA. So multiple codec can be described in standard way. Third is policy integration where Pipewire or Android HAL. So switching decisions are actually useful in real time. And finally, talk to maintainers and do the upstream in ALSA. Now this is a crucial, because unless this might standardize, we'll end up with fragmented vendor specific solutions. This is not solved problem, but it's an opportunity for collaboration across community. So now we are here at the end of the presentation, and I'd like to summarize that today we discussed that Linux does not allow real-time codec switching, and that is a real blocker for automotive. Imagine a EV. What we have outlined how ALSA could evolve with a scheduler, shadow buffer, and codec profile in device tree. It's challenging, but it's achievable. And more importantly, it's worth it because this now it's not about just a performance. In safety systems like eCall, it makes the difference between reliable connections and failed one. So I'd like to invite community people to come forward, analyze, plan, execute the next steps together. I hope you have enjoyed the presentation. Thank you very much for having me today. Bye bye.
Thank you very much to Rutledge. Brilliant. Rutledge, are you going to be joining us for a bit of Q&A after this session block in Gather?
Sure, I'll
Brilliant.
Ben. Thank you.
Fantastic. So after this block of sessions, if you head over to Gather, Rutledge will be there in the main auditorium to answer any questions you might have about the session. We are running a few minutes ahead of schedule, but I think we'll just bring in the next speaker now, and then that means we can have a slightly earlier break. So I am now delighted to invite to the stage Jorge. So let me just bring him into the webinar. Be with us in just a second. And Jorge is going to speak to us about learnings from a decade of being a mentor in game audio. So, Jorge, if you'd like to share your screen, and I'll hand over to you.
Okay, fantastic. Thank you, Jim. Okay, right. Hello, everyone. Thank you for coming to my talk. I hope what I'm sharing with you in this presentation is of help, independently of your mentoring experience or familiarity with the game audio field. So all that said, I shall introduce myself. I'm Jorge, currently a software engineer in audio based in Madrid, Spain. I started working in games in 2008 at EA, a short stint in the localization studio the company has in my city, and I've also worked for some mid-sized and large companies like Codemasters, Activision, Mercury Steam, and Zynga on some high-budget games, or AAA as we call it in the industry, like FC, called previously FIFA, and Guitar Hero Live. Something personal, from time to time, I also enjoy hiking, reading about varied topics, and traveling. So here you can see me in one of my summer trips. So first off, why become a mentor? There is a bit an old study from 2018 referenced by Forbes in the link below. A couple of key takeaways are that not many people have mentors, and most of the mentoring relationships develop organically versus in more structured programs. Now, why am I giving this talk? I actually started mentoring formally in 2018, so as part of some game audio mentoring programs, perhaps I should have titled this talk Learnings from 7 Years of Being a Mentor in Game Audio, but a decade sounded much better, so I hope you forgive me in this case. Anyway, the motivations behind this talk have been the same. When I started asking around what was required to be given the senior title and benefits, a common theme people mentioned was becoming a mentor. So in some way, this was part of my selfish initial motivation for becoming one. Also, developing leadership skills while learning from others and having a sneak peek on management were driving motivators. In my own career at companies such as EA or Activision and others, mentors paved the way for my success. So I became a mentor at first because I saw it as necessary for my career, and that's a really valid reason to start on the path. But as I went down the path, I came to value more being able to give back to others. With this talk, I will be also trying to convince you very hard to become a mentor or to do more mentoring. Let's see if I can do it. Here are some of my learnings about mentoring modalities after a few years. These guidelines have also come from the Code of Conduct and some of the previous mentoring programs I've been part of. So on one hand, we have structured. Perhaps in part, the ADC mentoring program is one of them, as it encourages to set an agenda and goals and some initial expectations, which help to set the stage for the mentoring relationship. Also, continued feedback is mentioned, and I've seen it's also helpful for some mentees. On the other hand, a less structured approach is also very helpful. More ad hoc casual, informal, organic conversations that can really happen anywhere, between coffee chats in the office or on Slack or Teams. I've experienced both approaches in the past, and I personally think that while the less structured approach has worked better for most of my mentees, and also when having mentors myself, I feel that having at least some structure and expectations set at the beginning also helps to have a more fruitful mentoring relationship. So, what a good mentoring relationship looks like? Well, ideally, we want to reach a win-win situation where we have mutual trust and respect, supported by defined boundaries and expectations. We also want to experience professional interactions that at the same time are personals, since we are all humans in the end, right? We also need to be mindful of personal requirements. For instance, I've had some neurodivergent mentees in the past, and I've tried to accommodate as much as I could to help with their schedules by offering flexibility on meeting times, for instance. Most importantly, I believe that a healthy mentoring relationship should be one where both parties are learning from each other. So, in some way, it's less one-sided. Now, what a great mentor looks like. In this slide, I have a list of items that I have compiled from some manual and recommendations, and they have been a guiding set of values for me. I should say that some of them have been more aspirational than practical, but I also think they are also key for becoming a good mentor. So, for leadership skills, of course, listening, having empathy, and patience are key while questioning mentees on their assumptions. We ideally want to guide and promote independent thinking and facilitate conversations or career decisions. One of the things that many mentees also like to hear are past experiences so that they can have a better understanding on your own path and how it can relate to them. Additionally, behaviors that we want to promote are open and honest communication while giving honest and actionable feedback. Not less important is to celebrate the achievements of mentees and to advocate for them when possible and necessary. The last few slides have been a generic introduction to mentorship, and so far I've talked about it as a general topic. But what about game audio in particular? Let's take a look. In my view, game audio has its challenges and opportunities, as with any other creative and tech-based industry. How does this relate to mentoring? Game audio is niche compared to other tech fields like web development. We also should have in mind that usually job descriptions, as in other tech industries, could be vague and perhaps don't help to understand the roles we can find in the games industry. I will touch on this later. Audio is just another pillar, an important one in games development. I'm just mentioning it here because having this in mind can help differentiate opportunities with others in audio and music technology. The final product that a games company creates is a game and not a piece of audio technology or tool. But thankfully, in the last decade, audio has become increasingly important and identified as key for the success of games in many studios, which is great for us working in the field. Also here, I will also like to say that there are opportunities for doing interesting work while working closely with other game disciplines like animation or graphics. There is also a high potential to innovate in the field, one of my personal motivators that has kept me in this industry so far. Okay, so what are the typical individual contributor roles I see that you can find advertised in game studios? If you want to be mentors in game audio, first we need to understand the different roles. I will say that these are the big four with different flavors and definitions. Some companies use sound and audio interchangeably for designers working in content creation, while as part of the audio art part of the game, there are even some companies like EA that call their sound designers audio artists. On the other hand, we have the most technical roles, perhaps closer to the audience in this conference, and so people that you are attending, people like you that are programmers and software engineers. So about the design roles, we can usually find a spectrum of technical skills. This varies depending on the company, and expectations could be different. More details on what each of these roles do later in this presentation. If we talk about programmers and software engineers, there is an agreement in the industry that there are at least 3 different disciplines or sub-specializations. People working more on the gameplay side of the game, others working on tools and pipelines, and then we can also find people working on rendering and DSP technology, for instance. All are required to make a great game, but the need of specialists for each area will most of the times depend on the budget, the scope, and even the company culture. You can also find people in the industry that can do a bit of everything, that's great, or that have a broad knowledge across specializations. I also wanted to focus here on the fine line that technical sound designers and audio programmers, and to some extent audio software engineers, can find themselves. At least what I have experienced, the title sometimes doesn't matter much, as both of these roles could be doing by similar jobs in a game studio sometimes. Now that we know the different roles, we can see different career paths and how people will need to develop in different ways. Here I wanted to share some of the career paths I've seen my mentees taken and some ideas around the advice I try to give people that is interested in breaking into the industry. From left to right, I laid it out intentionally. We can go from more design roles to the most programming and technical roles. This isn't meant to be the only valid career path, as it's just an example. Please bear in mind that these descriptions are meant to be more about the roles stated in the central orange timeline, not much about the titles. For instance, a sound designer could be also doing technical sound design as part of their role. The majority of mentees and people I have mentored in the last decade have fallen on technical sound design, audio programming, and audio software engineering. So what if some person wanted to work as any of those? Here's a personal opinion on what are the entry points to jobs with an example that is illustrated in this diagram. My motivations in mentioning these are to help clarify what are the possibilities of getting a job in a now very competitive market and volatile industry. In my view, someone wanting to get a job as a technical sound designer should already know about audio and tech fundamentals, show an interest and skills in the technicalities of games and game design knowledge, as well as familiarity with middleware and integration, for instance. They should be interested in developing programming skills, as many, but not all, sound designers find often themselves writing scripts or small tools, or even writing small extensions or plugins in C++ for game engines and middleware. In any case, technical sound design roles can vary a lot across companies, some focusing more on the actual design of the game using node-based editors and much less on programming. On the other hand, and I will refer to audio programmer and audio software engineer interchangeably here, since both titles in different companies could be very similar or even the same, a strong candidate should already have programming experience or an engineering background. Unfortunately, junior or intern positions in the industry are scarce, so I try to be mindful of that when giving advice. Another entry point some colleagues have shared for audio programming is audio technology quality assurance Q&A. All that said, just to give here an example, one of my past mentees did the transition from sound design role to technical sound design and then to audio programming. Unfortunately, getting a programming position these days without any professional programming experience is mostly unlikely. So the advice I try to give my mentees is to carve a path progressively. Of course, as in everything, there could be outliers and exceptions, but in my view, making the transition from sound designer to audio programmer takes time. It could take a long time, and it isn't trivial if starting with programming from the scratch. Which leads to some of the practical approaches I found for cultivating unique talents. So here I wanted to use an analogy. My partner and I have some plants in our apartment that we have been taking care of for more than half a year now. So I thought that my experience with them could be used for helping me to make a point. First plant on the left mostly has had the need of getting water. It has beautiful, gorgeous flowers. Looking at it and giving it water works great, and it's currently thriving. The plant on the center at some point in time started to deflate and go down. One day my partner said, okay, maybe it needs more space. So I moved it to a bigger flower pot. After a few days, we noticed that it started to grow more and still needs water too, of course. The rightmost plant has been a challenge. It has been always small, giving some flowers only during spring. Unfortunately, giving it just water didn't work out. We had regular check-ins and unfortunately it didn't survive. I hope this doesn't trigger you much. A learning here for me is that we should have investigated what it needed more earlier in time, and we should have had perhaps more regular check-ins. So how does this relate to mentoring? Now let's talk about my mentoring experience for cultivating unique talents and how we can also act as gardeners with mentees. I think what I found with time is that helping the mentee identify their skills, strengths, and needs is more than not a key to success in mentoring. Asking the mentee and observing them, asking some questions to gather what they are good at, what their interests, what do they need to make a living. The intersection of the three is one formula I found helpful, and I think it's also an enabler. There are some texts and guidance you can find online that talk about purpose. In my view, this is key for a sustainable career. If you are an experienced programmer or engineer, you have seen this in yourself. There are always ups and downs and challenges to face. For me personally, having a purpose has been helping me. Talking to others, to colleagues and friends in other industries like education, also mention purpose as a good tool to motivate people long term. I also need to remind myself sometimes that different people can have, of course, different purposes in life, and that is completely fine. So, what are some of the tools to help mentees find their interests, learnings, or find maybe their purpose? I've split them into 3 different categories, and I know some other people might have other tools. So I would love to learn what you do. I found that supporting materials, encouraging opportunities research, and network development are perhaps the most useful. YouTube videos and presentations from conferences like this, ADC or GDC, books like the fantastic Game Audio Programming series edited by Guy Sonberg, or attending conferences and meetups around the world are great resources for learning and for connecting with peers. Now that we are getting short of time, I wanted to share some of the recent feedback, anonymized, I got from previous mentees. Here are some of the highlights to demonstrate if what I have presented works or not. These are positive comments that show a testament to the benefits mentees can get from a mentoring relationship. And they also motivate me to keep me doing mentoring. And these are some areas of improvement, which have also been opportunities for learning and growth for me. Common theme is that working on a particular project together seems to be very valuable, though sometimes it's challenging with time constraints. On the other hand, there are people who prefer more structure, which also helps everybody with busy lives. So, to wrap up, please get involved. I think a common theme I've regularly heard for the organizers of mentoring programs is the lack of mentors to fulfill the demand. In audio, and of course in game audio in particular, there are usually more mentees than mentors. So just remember that mentoring is win-win. Both parties are learning. It's a great opportunity to give back and pay it forward to the community. And also, mentoring helps make a more inclusive, strong, and supportive industry. So please consider helping out. Now, I would like to thank Guy Sonberg from Blizzard Entertainment and Colin Walder from CD Projekt Red for their feedback and help on this presentation. And I will be happy to take any questions if you drop me a message or find me online on Discord or Gather. Thank you so much. And here I have some mentoring materials in case that you need them. Thank you.
Thank you so much, Jorge. That was amazing. We'll just keep that up for a moment just so that people can take a quick look at your final slide. But we appreciate you very much for being here. Thank you. Are you going to be around after the session if people have any questions for you in Gather?
Yeah, I'm aiming to join Gather now and will be also available on Discord during the day for
Brilliant.
some
Thank
time.
you. Thank you so much. So if you are joining us in the virtual venue, I'll just quickly show you. You can head over to the auditorium. Let me just move my Zoom bar. Head over to the auditorium here. And when you're there, you can step into this. There's a tile. This is my character here. I'll zoom in a bit so you can see me. Here I am. If you step into this orange megaphone tile that's in front of my character here, you can step in and ask a question. The speakers will come and step into these pink tiles on the stage, and at that point, if you step into this yellow tile, you can ask a question and everybody in the room will be able to see and hear you. So make sure you're in the tile if you want to ask a question. Step out when you've finished asking your question, and allow another person to step in. And so, Jorge, if you make your way over there, step onto the stage and along with the other speakers, and it'll be a group Q&A session. Brilliant.
Thank you so much, Jim.
Oh, thank you. We really appreciate you being here. Thank you very much. I'm going to send you to the backstage now. If you're joining us on YouTube, so just be aware, we're going to go for a break now. Let me just stop sharing my screen. Yes, so we're going to go for a break now. We'll be back in the stream at 13:50 UTC. If you're joining us in the virtual venue and you've pre-registered, you can come and join us for the poster session, which is happening exclusively in Gathertown. That will be starting at 13:20 UTC. But otherwise, we'll be back here, as I say, with the talks again at 13:50. So we're going for a short break. All right, thank you all. See you very soon. Hello, hello, hello. Right, we're about to get started again with our second block of talks for ADCx Gather 2025. The first presenter I have for you is Johannes. So Johannes is going to be speaking to us about community and sharing in native audio apps without browser overhead. So Johannes, if you'd like to share your screen, there you go, brilliant, that's up and running. Hopefully you remember to share your sound, and I'm going to hand over to you to please begin your session. Thank you very much.
Thank you very much, Jim. Hi, everyone. Thanks for joining me at ADC Gather. This talk is about community and sharing in native audio apps without the browser overhead. This is quite a mouthful and probably poses many questions. How did we get here? Let's take a step back and recap essentially where I'm coming from. What led to native communities in audio applications? I was always wondering, why do we still sell synthesizers as a whole, even though in-app purchases and freemium models are everywhere nowadays? There are some subscription models, but those come with their own drawbacks. Why don't we sell presets instead of the synthesizer? So if we sold presets, people wouldn't have to cash out a couple $100 in the beginning. You just have a very low entry barrier, jump into the synthesizer, and in the end, you can selectively unlock single presets. Wouldn't that be a cool thing? So this would pose the next question: where do these presets come from? Maybe they should come from the community. Maybe it's just not just the manufacturer creating these presets. They should come from the community. Everybody should be able to share their presets. And if those presets are sold, so if you don't sell the synths, but the presets instead, shouldn't the people that actually create the presets get a share, even if it's just people from the community? And the next question that's going to be there is, how do we handle DRM? So if we don't sell the synth doesn't have copy protection. If we sell presets, they need to have some kind of copy protection, so you can just share them around on file systems, file sharing platforms. So we have two goals now: preset sharing and value participation. What are the bare essentials we need for these two goals? Well, we need to have the users inside of our synthesizer. But if they want to be able to share their presets, they need to be right there. We need to somehow figure out, what is a preset going to cost? Is it going to be a fixed price? Is it going to be something dependent on the complexity of the preset, on its popularity, etc.? How is that going to be? And there must also be a way to share the revenue of a preset between the author, because we want to give something to the author, and the manufacturer. Then there are many other questions coming up. What if multiple authors contribute to one preset, for example? So a preset could be a conglomeration of different authors. So the revenue would have to be split between them. Or what happens if a preset is based on another preset and somebody shares it as his own preset? Is the original author going to get a share? So we're opening a can of worms here. So let's look at the preset sharing and value participation goals one by one. What ingredients are required to enable preset sharing? So we need a network infrastructure for sharing. We need some kind of server that hosts presets. The synth must know how to communicate with that server and how to get the presets. We need a way, as said before, to figure out pricing and distribution of the prices. And of course, we need countermeasures against unauthorized file sharing. So essentially, yeah, if you sell presets, they shouldn't be, they need some kind of digital rights management. And would you buy a car without driving it first? There needs to be some kind of way for people to actually use presets before they actually purchase them. So you might make productions, you produce something, you play your preset in your DAW, and you want to be able to hear the sound exactly in that in the way that you want to play it. You don't want to just hear a static preview. So one way to enable this would be audio watermarking, where you have some little noise play in the preset, unless you unlock it. But you can use it completely in all aspects. So second goal, participation, value participation. Even if we have all the ingredients from before, what else is required for value participation? We need a unit of value. In this case, it might be something credits, like an in-app currency. We need a way to exchange credits and currency. So we need to be able to buy credits somehow. And if somebody earns credits, we need to know that they earned the credits, and we need to be able to pay out for those earned credits. And of course, authorities also want value participation. So we need to be able to transparently document all the transactions that are done, that are being undertaken. So what are the results when we combine all of these ingredients? First and foremost, the users must be inside of your synth. They can't be outside anymore. Users need to be able to upload and download presets. And if we do the entire thing where we put users into the synth, wouldn't it be nice if they were able to interact, if they could write something to each other, if they could see each other, maybe, yeah, do all these community things. The picture becomes quite clear now. We need to bring a real community into this synthesizer. All right, so communities and synthesizers. How is this currently handled? Usually communities are not in the synth itself, they're somewhere outside. They're on forums, on Discord, they're just segregated everywhere. If you want more presets than what's inside of what is shipped with the synthesizer, you have to find it somewhere else, or maybe you can find some preset packs. You can find some stuff on file sharing, maybe. There's usually no DRM, so it's out, it's the wild, it's out in the wild. There's no direct connection between users also. You don't really know anything. So what we want to do, like the current landscape looks like there's an island with a synthesizer, and there are many communities around it, all segregated in different places. We want to go from there to the synthesizer, which actually has the community integrated inside. So how do we accomplish this? We could use a sledgehammer to crack a nut. We just embed a browser into our app. From my experience, it's quite heavy. It's awkward. It has cross-platform chores. And if we already are in the C++ realm, why do we have to go to JavaScript? It doesn't seem perfect to me. Plus, we would have to maintain a central server, get our heads wrapped around the entire web stack, PHP and Nginx and whatever. It's costly, it's a lot to maintain, it's complex. Or we could try to outsource a community to a third-party platform, but usually third-party platforms never quite fit the use case perfectly. Plus, the users are still not in your app, they're somewhere else. It's segregated again. Nothing of that seems to be feasible or very good. So what if we approach this differently? Imagine we would build our own framework and adhere to 3 design principles and see where this gets us. First and foremost, let's stick to what we know, at least in my case, C++. There's not going to be any browser bloat. There's no friction between different languages, no strange tickling of our taste buds in the end. Secondly, we don't want our community to leave our beloved synth. It should be in there. Let's keep it within our comfortable environment. And lastly, if we like to use it, others may also like to use it. So keep it modular to cater for different use cases, for different community. Have it white label so it can adapt to different styles. So if we want to support multiple communities, it might be a good idea to wrap communities. So it might be called domains, which is a lightweight infrastructure to wrap an entire community essentially. It encapsulates all the information you need for a community in domain configuration files. So essentially, a domain configuration file tells information about the features and about discovery and communication. So there are two parts of the configuration files. There's a server and a client part. And there's a dedicated native server executable. It's just a single app. It doesn't run any Apache, or you don't need any web stack behind it. It's just a single app that you can run in a data center, or you can run it on your own computer, wherever. And you load in a server configuration file. And in the synthesizer, you load the client part of the server configuration file. And this is all you need in order to communicate. So this way, a synthesizer can communicate with a server. It's a very specialized server. It's not not for everything. It's just built especially for this use case. And since we're loading client parts into the app, we can support multiple domains. So, for example, you might want to have a preview domain environment that has some features built in that are not currently released, just to not interfere with your live domains. All right, so we got the domains out of the way as a means of encapsulating communities. What about users? How do we picture users? We all love juggling passwords. We like to forget them. Requirements usually change. They need to be more complicated. In the best case, we should be changing them every now and then. And of course, we should never use the same password at many places at the same time, right? It's a hassle. It's not very easy. You need password managers and whatever. But there's a way to avoid all of that. Instead of using username and password, you can just use cryptographic identities. It's kind of like the same way as cryptos work. So you have your 24 words as your backup recovery phrase, and everything else is done through the identity itself. So you can have one identity, and if you maybe want to use multiple synths or enter multiple domains, you can just use that one identity. You don't need to create users for all the domains and stuff. You just enter with one identity and you're all set. And all the passwords that are necessary to enter domains or to host domains, etc., they're just all derived from the identity. So you don't need to care about this. It's secure, it's portable, and it's simple. And a great side effect of this entire thing is that we don't need to collect emails for verification or password reset links. It's the best data protection is if you don't have data in the first place. The only thing is that users just shouldn't lose their 24 words, because otherwise their identities are gone. All right, so we have domains and identity. The next ingredient is the presets. This is what's all about, right? How do we handle our presets? Should we simply exchange binary or JSON files? Probably not the best way to do this, because there's no DRM, at least not inherently. And there's also no inherent way of distributing earnings. We need something better, so we came up with a approach that I call structured content. Essentially, if content is modeled on key value pairs, such as presets, for example, you can register all these presets and their parameters together with the ranges, and you can give a weight to each parameter inside of a model. And then there's a dedicated parser, which actually works with the models and does everything else. So once you registered all the parameters in the model, all the distribution calculations, etc., are done from there. The other side of the model is the configuration. This is determining how the pricing is calculated for a preset that is based on a model, and how the earnings are distributed between all the authors. if sub presets, so essentially the model is hierarchical. So you can have sub presets in the model, and each of these presets can have a different author. And if you want to unlock an entire preset, then all the authors, all of the sub presets are being rewarded as well. And the way these rewards are distributed is determined via the configuration file. And there's also the other use case where somebody downloads a preset of somebody else and changes it a little bit and then uploads it as his own preset. And in this case, we want to be able to reward the original author as well. So if you think of the preset space as a landscape, somebody might put their flag into the landscape, and where you put your flag, you have a claim zone around. And if somebody else puts a flag in the vicinity of your own claim zone, then his claim zone is going to overlap your claim zone. And in this case, the second preset is going to have to leak some of its earnings to your preset. And the exact way how this is calculated can be configured via the configuration files. So we have structured content, which is key value pairs, but we also have other content, which might be, for example, a profile of a user or a blog entry or pages or all these, or maybe just a message in a conversation. To do this, I actually started writing a C++ Markdown parser. And this turned into a fully fledged what you see is what you get editor that supports widgets, views, scripting, expressions, and there's still many more things to come. So it's quite easy to actually build pages with that. And the background is just text, but it's being passed into interactive content. And it can also include gated sections. So for example, you might create an advanced tutorial where maybe some of the inputs are being behind a paywall. Or you could, for example, make a list of presets, your own your best pick of presets, and if somebody wants to see it, they have to remove the paywall behind it. So yeah. The next question is, so if this framework is built in such a way that it's encapsulated and that it's easy to use somewhere else, how hard would it be to integrate it into other apps? So it's done in a way where the work wraps your UI. You don't have to do any changes to your UI. Your UI stays the same way it is, and the framework just attaches to it on the side, as you will see in a second in the live demo. You can brand it with your fonts, colors, and spacings, and the most work is going to be to register the actual parameter model. And of course, track the changes as well if these are changed. And then there are also callback mechanisms. So, for example, if you want to have a button somewhere in a blog post, and clicking on this button should trigger some kind of functionality. So enough talking. Let's have a look at the system in action. So let's say we have our synth here. We built a little preset, and we gave it a profile, wrote some text about it, and now we look at the preset browser to see what else is in there. So this side on the right side, that's the community part of it. You can make it visible or not. And let's see, for example, here, Stefan has uploaded a preset that's called Shimmer. I'm going to load that and play around with it. So maybe I like this preset, but there's some awful noise in the background, right? It's quite loud as well. So let's say we want to remove this noise in the background. We can go to unlock, and now we can see, okay, it costs 93 credits to unlock it. Let's see how many credits I actually have. Let's see, can I afford it? Okay, I can see I have 200 credits on my account. So what I'm going to try is unlock. And okay, this was a little bug here. Usually this lock should have opened, and the noises should have gone away. Let's have a look at another example. So essentially, I'm going to load this preset again to have to remove the background noise. So let's see what else we have here. We can go to the home page. We can see we have some blog entries. There's a release note. There's an artist spotlight, review roundups. By the way, you can always expand the community, make it big, and see it in full screen. There's also a learn section. Let's have a look what happens here. You can click to go. So here's a little quick start tutorial. And it asked me to load the initial patch at first. So I'm just going to click this, and it loads the initial patch. Now we have kind of a boring patch. And the first thing it asks us to do is to change the modulator to the envelope mode. Which one is modulator 1? Let's have a look. Maybe if I'm here and I change it, was that correct? No, it was not correct. It looked like if I change this one to envelope, let's check it. Yes, I've set the envelope. So it's just an example on how you can do interaction. Now it asks me to higher the pitch by 12 semitones. It should be 12 up, so I go to the pitch dial, put it on 12, and now the pitch is correct. This is just a very small and easy example. It can be much more elaborate, of course. Another thing here might be some discussion board. So we can see we have like a forum-like discussion. We can also make it big to see it a bit better. Let's go in here. And we can see we have somebody asking something about a baseline with a grid. And we can just write a reply. Bases always need speakers. And post this. Bam. So it's in here, and we can go back up, for example, see the messages. We can look at his message and say, okay, maybe we give it a thumbs up, and then it gets the thumbs up tag. And all of this is being built with the editors. So for example, if we want to look at this homepage, we can go into the pages and look at the home page. Let's make it big. Let's go and edit it. And here's the editor for the home page, where you have these different things which you can lay out your content with. It's quite flexible. But I think we might be low on time. I'm switching back to the presentation. All right, so we've seen the presentation so far. So this is a way to bring communities into the app. It's purely inside of your app. It's nothing, you don't need any external frameworks or other technologies. It's very lightweight. It keeps the infrastructure quite simple. The identities allow you to go to different domains and exchange domains without all these password hassles and all these things. The credit system drives fairness because it distributes the credits between the authors. And there's also other ways you can use credits for unlocking gated content, etc. And the integration is not too much effort. Essentially, it's just 3 header files. It's a model view controller pattern. And I guess the biggest integration hassle would be registering the models for your, yes, registering the models, exactly. So that's it. I'm not sure how we are on time right now. Unfortunately, I don't have any timer here.
Hey,
I think-
Johannes,
yeah.
you are about 4 minutes over at the moment. So
Okay, I'm
if you
already
wanna just
over. Okay.
wrap up, that would be
Mhm.
wonderful, and I'll bring in our next speaker.
Yes, yes. Okay, so thank you very much for listening. See you next time. Bye-bye.
Brilliant. Thank you very much to Johannes. What a fantastic presentation, really engaging, and no problem overrunning a few minutes. That's great.
Okay, I'm sorry, I didn't have a time, so
No, but it's fine. It was a really great presentation, so worthwhile you taking the extra time to explain those extra bits. So thank you very much. Will you be joining for Q&A afterwards in the 10-minute break before the extended session?
Yes.
Brilliant. Okay, so if you would like to ask any questions, you can head over to Gather after this block of sessions. But now we'll say thank you very much, and I'm going to bring in our next speaker, which is Domenico. So Domenico, if you would like to share your screen, and then I will hand over to you.
But it doesn't let me share the sound.
It doesn't let you share the sound. Let's try this again. Try it one more time.
Yeah, now. Yeah.
Got it? Yeah, perfect.
Got it. Yeah.
Brilliant. Share the sound, and then I'll hand over to you. Do you want to just test it? Or
yeah, no, it's ready.
Brilliant. Thank you. All right. Handing over to you now. Thank you very much.
Okay. Okay. A few words about me. I'm Domenico Cipriani, also known as Lucrezio. I've been a DJ, producer, and live performer since the early 2000s, releasing more than 150 records and touring underground clubs worldwide. Since 2020, I've also been active as a live coder and audio developer, bringing programming into my creative practice. Now, I'm focused on developing audio musical libraries and APIs for Faro as part of my work with Evref Inria. Here's an overview of today's talk. First, we will look at the problem. Audio plugin development is often complex and inaccessible for many sound artists who doesn't have a deep coding experience. Then we will review the existing solution, the tools and the frameworks that are available today, along with their strengths and limitations. Next, I will introduce Fausto in combination with C Major. That is our approach to make plugin development simpler and focus on the sound and not on the boilerplate. We will also touch on monetization, so exploring a sustainable models that can support musicians. And finally, we will consider the new challenges ahead. What's the problem? Many sound artists and musicians want to create their own tools, but developing audio plugins can be daunting, especially for those without a strong coding background. Traditionally, this work relies on C++ or C. These are the best solution for performance, but these are difficult languages to learn, master, and use safely. Things like memory leaks and data races can lead to crashes or unstable software, making the process risky and time-consuming. Frameworks like Juice, that we all know and love, provide valuable support and help, but they don't solve everything. We still have cross-platform issues, macOS notarization, and other technical hurdles that still require significant time, effort, and frustration. So on this slide, we are looking at the same synthesizer, a pulse oscillator with an ADSR envelope and a generic UI, but is implemented in 4 different ways. With C++, it takes 485 lines of code. In C Major, the same scene drops around 50 lines, and with Faust, just 24 lines. With Fausto, we can express it in only 5 lines. This is, of course, just one example, and it's not all about the lines of code, but Fausto abstracts away much of the underlying complexity. So instead of dealing with hundreds of lines of low-level code, we can focus really on the musical ideas and the sound itself. Let's see how this at the solutions we have now. So if we take, for example, Max for Live, it's powerful, it's easy to learn, but it's not free, and it only runs in Ableton Live. Then there is, for example, plug data, so pure data, but its libraries available are scarce, and its performance are questionable. Similarly, at the same time, we code written in Faust, we can produce audio plugins using Faust VST or ICE toolkit, but functional programming can be hard to learn. C Major is a much easier approach. It allows us to get started faster, but even here, beginners can struggle. because you still need a solid understanding of JavaScript to build UIs, for example. This for the UI part. Essentially, every existing solution has a trade-off. There is power versus accessibility, performance versus ease of use. A real solution for artists would be a tool that balances open access, easy learning, cross-platform functionality, and intuitive design. So, what is Fausto? Fausto is a new library for DSP programming in Faro Smalltalk. We will see in a bit what is Faro Smalltalk. At its core, Fausto integrates a full Faust compiler, and this gives access to hundreds of unit generators from Faust standard libraries. We have basic oscillators, complex reverbs, delays, flangers, distortion, algorithms. Everything can run smoothly inside a friendly, dynamic Smalltalk environment. Fausto stands out for its export capabilities that are derived from the Faust compiler at its core. So our creation can target multiple languages, including C major, and these unlock new possibilities in audio development. C major patches run perfectly on the free plugin, loader plugin available from the C major team. And so we can directly deploy our audio applications immediately. No boilerplate, just sound. Fausto doesn't just create C major code, including helpers for polyphony, but it also generates the necessary JavaScript files for a complete UI. So Fausto bridges three words: Smalltalk's elegant development environment, Faust's audio processing expertise, and C major modern deployment ecosystem. Altogether, it's audio programming without complexity barriers. And I would like to say that I don't see any exclusion between Fausto, Faust, and C major. I think that musicians and producers can be attracted to code through Fausto, can later move to Faust, and then to C major. Writing Faust code, for example, could allow them to implement a reverb from scratch. And C major knowledge would be extremely valuable if they want to add audiophile support to their plugins. Few words about C major. C major is a C family language created specifically for writing DSP code. Its creators say it's designed to improve the status quo of audio development by making it more accessible without sacrificing performance. Unlike traditional C or C++, C major was built with students and beginners in mind, so it offers a softer learning curve, and it can avoid common pitfalls like data races or out-of-bounds error. At the same time, it has efficiency and speed that professionals expect. So C major patches can be loaded directly into any standard DAW using the C major plugin. And that eliminates multi-platform hassles and the nightmares of notarization. What is Faro? Faro is a pure object-oriented programming language that comes with a powerful IDE that is designed for simplicity and immediate feedback. Faro represents a contemporary evolving takes on Smalltalk, and that's a focus on modern tools and workflows. It's free, open source, and multi-platform. It has the simplest syntax that is easy to pick up. Its IDE is powerful. It offers integrated Git support and advanced runtime reflection, so we can inspect the system and the object at every time. And development is so smooth and efficient. On the top of that, Fausto brings DSP programming into Faro, so in the Smalltalk world. So it makes accessible audio development to artists and Faro programmers. Learning Faro is fast. We can get a solid foundation in 7 weeks or even less with this online MOOC. And with Fausto, we can be productive in just 7 days using the Master learning tool inside Faro. All right, now we jump to Faro and we see how we can create a plugin with Fausto, export it to C major, and load it into a DAW. Okay, here we can create an instrument. Here, this pulse oscillator with the ADSR envelope is just one line. I will be happy to discuss the detail of this code later in the QA or in the poster session. So we create this synth, then we convert the synth to a DSP. This is made by the Faust compiler. We initialize and start the synth, and we can display its UI. Once the UI is displayed, we can try the sound. Okay, now we know it works. So we can create a new C major MIDI patch object. We can create MIDI patches or FX patches. And once this is created, we can export it. When it is exported, we have a folder created with the name of our patch, so pulsar in this case. So now we can open our DAW or choice and just drag and drop the C major patch file into the plugin, and we can run it. It's working. So what if we want to do our own UI? So we can with Fausto. This was the generic UI provided by the C major team. So if we want to provide our UI, we can with Fausto. We need PNG, SVG, or JPEG file, and we can arrange them, give a position, and assign it to a parameter. So we define a background, we define a knob, we define a fader, we create a view, we add the knob to the view, we add the fader to the view, and finally, if we jump back, we add the view to the patch. So if we jump back to the plugin, it's auto-reloaded, and we can see that the plugin has these two controls. We just defined two controls, so we see only two controls in the background. Okay, now we can jump back to the presentation. We see that we can, to use a C major patch in a DAW, we have to drag and drop the C major patch file into the plugin. Well, let's talk about the distribution and the monetization. So to share our C major patches, we can distribute a zip file that includes all the plugin files, so the patch files, the UI assets, and the license text. This makes it easy to share our instruments and effects with friends and our fans. Once that the users have downloaded the C major plugin, they can freely drag and drop different patches. It's important to note that there are a portion of the Faust libraries, like for example, reverbs or filters that are copyrighted. And so to distribute these Fausto unigenerators legally, we must include a copy of the original license. We are working to have an automation of this process, so something in Faro, in Fausto, that can generate the license and include it in our folder. But what if we want to sell our C major patch? Well, one option is Bandcamp. Here you can see the soft computing Bandcamp page is the indie punk software house I'm running with DJ House, or Unknown to the Unknown, where we are selling our VST and Max for live devices and also sample packs. Well, in Bandcamp, we can add bonus items to our releases. So if we create an album release and we add some few audio demos of our instruments or effect, we can attach a zip file with all the necessary files as a bonus items. And when somebody buys the release, Bandcamp delivers the music and the zip file together in the same package. And because development time is so much shorter, we can keep our prices low if we want. And in the release note, we can, for example, put a direct link to the free C major plugin so users can find it easily. So instruments and effects that are built with Fausto can be distributed just like our independent music, affordable, artist-driven. What are the challenges for the future? Well, when we talk about the future of plugin development, there is a big question that comes up. Does it still make sense to code our plugin? Does it make sense to use Fausto? Shouldn't be that made with AI? Can the AI do the plugin for us? Well, I think it still makes sense because if you want to stay part of the creative process rather than automate everything, you can learn Fausto and start with audio development and then maybe go to a more complex tool and language or continue using Fausto. In my opinion, AI can broaden our perspective and can help us to build more complex tools, but it should not replace the hands-on exploration that makes music unique, just like making music, also like making audio instruments and effect is a musical and creative process. For Fausto and C major, I see two big challenges. The first is a way to build more complex UI, so not only based on PNG, SVG, and JPEG files, but keeping the API simple. And then the second, as we would like to have those support for C major patches directly without having to use the loader plugin. That should be done soon in the way for DAW. And for all the other DAW manufacturers, well, the more C major users we have, maybe the more push is done to have them to support this framework. Grazie, thanks everyone. A big thanks to the ADC organizers for having me here, the tech crew for keeping things smooth. I want to huge thanks to Avref for backing my work and to Stefan Slets and Cesare Ferrari for their technical help. I will be in Gather Town for the Q&A and I will be at the poster tent, so come and find me and ask questions or just have a chat. Thank you very much.
Thank you very much. That was amazing. Thank you, Domenico. Really appreciate that. And we will be now bringing in Simon in just a moment. So, Domenico, will you be joining us for Q&A afterwards in Gather? That will be at 14:50 UTC.
Yes.
Brilliant. Okay, fantastic. Thank you very much. So I am going to bring in Simon, and I'm going to push you back to the backstage. Thank you very much indeed. Move to backstage. Okay, Simon was just having a couple of issues getting his audio sharing working, so just give us just a couple of minutes and we'll be back with you. We just need about 1 minute or so just to get him up and running, so just hold on here for one moment and I'll be back in just a second. Hey everyone, we're just padding for a moment. We just have a one technical issue with the speaker backstage, just getting his audio sharing working, and we'll be back in just a second. Alrighty, thank you very much for just holding on there for a moment. We're ready now to bring in Simon. Sorry for the delay. There was just a slight change to the setup which caused a momentary issue. So I'm bringing in Simon now. And Simon's going to join us to be speaking about the immersive score, creative advantages of beds and objects in film and game music. So that's creative advantages of beds and objects in film and game music. So Simon, if you'd like to share your screen, and then I will hand over to you. You will need to share your screen again, just because we've come through to the live webinar. Brilliant. There you are. And there you are there. Did you just want to test your audio or anything before you go?
Yeah, it seemed to be working earlier. So
perfect, brilliant. Well, I'll listen in, and if I hear anything, I'll let you know.
Wonderful. Hello, everyone. So good to be here. My name is Simon Ratcliffe, and I'm a score mixer, and I mainly deal with games and films. I'm not a coder or anything like that. So this is really a much more of a look at some of the creative elements for how we can be using object-based audio with a focus on Dolby Atmos and object-based embeds audio in games and in films and other media as well, just to really kind of get stuck into some of the really creative elements of how we look at binauralization. So today we're going to be looking at difference in practical mix and sound design applications and the behavior of beds and objects. Because I think one of the things which kind of falls off is that we get very caught up with the speaker-based side of things. But of course, when it comes to the vast majority of consumers, especially on the game side of things, it's very much headphone-based, and a lot can be done to really push things in terms of storytelling, and it's really having a lot of fun in terms of sound design when you look at how you can treat beds and objects differently in terms of how they're treated binaurally. I also want to have a quick look at the difference between a creative binaural encoding such as Atmos and binauralization of content for monitoring. I think sometimes there's a lot of people conflate the two, and then some tips and tricks for acoustic and electronically generated sound. I'm going to encourage you to plug some mics in at some point, not today, but in the future. And then a couple of pitfalls as well that we can avoid. Things that sound really great on speakers, but just really don't work on cans. So just to clarify the second point, this is a screenshot of Virtuoso, and this is not an object-based or Dolby Atmos or anything like that system. This is purely a monitoring system. I find it extremely useful when I'm not in the studio, if I'm going somewhere else and I'm on headphones, just to go, okay, well, I was working on this in an Atmos system. I'm on the road now. I'm going to use the software to binauralize where my speakers would have been, and that is not what Atmos or object-based audio is. And I think sometimes when people look at Atmos and things like that, they go, "Oh, okay, great. I'm using a binauralized setup." But what the binauralization in Atmos and object-based audio is doing, of course, is figuring out a way of taking a creative element in a mix, which was speaker-based, and applying that in a way that our ear can go, "Okay, I can hear that source element," as opposed to recreating a room monitoring environment. So I'm sure a lot of you know this already. However, it is marked for beginner and intermediate. So I thought I'd just quickly do a very quick rundown on the difference between beds and objects. So a bed, simply put, is a gang set of 10 objects in a channel-based or fixed pan configuration. So left, right, surround, and so on. And then the two overheads. Bed metadata is set per ADM, which is the master file. And within all the beds within the ADM have the same setting. And then of course, that's really very popular for things like ambiances and ambience type effects. Acoustic recording arrays are often used in beds as well. Objects, on the other hand, they have free movement through the immersive space. So don't think of it so much as, oh, it's going through that speaker or this part over here. The headphone way of thinking is actually much more pure in a way, because it's the entire immersive environment. Objects can be mono or stereo or wide channel. So you could create a 704 or a 906. So that would be 4 overheads plus 7 speakers as a monitoring environment, or 9 speakers plus 6 overheads, which sounds counterintuitive when you think of it as a 360. But that's nice thing about the Atmos part of it, the headphone binaural part of it, is that it doesn't address it as if it was speakers. It just addresses it as if it was a room. Objects cannot be sent to LFE natively, and of course you wouldn't really use low frequency effects or a sub channel for binauralization anyway. Each object has its own binaural metadata setting, as well as a size setting where you can increase or decrease the size of just the object. And they're very popular for sound design assets and solo instruments. I did a horror film a while ago, which was really cool because you'd have like singing voices and things like that in a theater or on headphones suddenly coming at you out of nowhere, which you can't really do in a discrete channel-based setup. So looking at the Atmos binaural metadata, again, I think a lot of the time we get so caught up with how it sounds in a speaker environment, we forget that it's really for many people about the headphones. So the way we look at beds, you've got, as I say, it's global metadata settings per session. Each bed channel can be set individually, but all the beds share the same. Sorry, each bed channel, should we rephrase, can be set individually. So the channels over here, but each session has a single bed setting, so it's global. And then I refer to something called Dolby's mullet, which is not a Dolby Labs endorsed haircut. That has more to do with their original recommended idea of, okay, we're going to emulate a listening environment, so you'll have the front speakers near, the side speakers mid encoded, and then far for the rear, for example. The objects, each object has its own binaural setting, and it can be independently panned, and it can be independently resized. And the nice thing about that is that you can move it then through space, up or down, or wherever you like, and the resizing causes decorrelation. Now, a big thing that I'm talking to you about today is the difference between the two, why beds and objects really do work very well together, and the advantages of having both. I think some people get very caught up in using only one or the other, but I think that they both do very different things, and they can do very different things. And the fact that objects resizing does decorrelation is one of them. A couple of things just to remind ourselves, in terms of binaural behavior, like really, I mean, I'm not going to tell you about HRTF. You guys know how that goes. But HRTF, spatial coding, and getting features of the immersive mixes stand out on headphones, I think are really key things just to remind ourselves about. So when you're approaching a mix or even a composition, it's a good thing to think, I'm, for example, not going to put a piano right behind someone's head because it's not going to sound very good. So with that in mind, just a quick reminder on head-related transfer function. The physical restraint of the fact that we have two ears and a big, in my case, a big fat head in the way, means that we have certain aspects of sound which are time domain and frequency domain dependent, but then it hits your head, that it rolls off in a particular way. We also have relatively poor perception of direct sounds behind us. In a speaker setup, you can get away with it. Headphones, it really honestly often sounds like it's in the front, but just with the high frequency roll off because of the transfer function of the EQ. And then of course, relatively poor perception of height front to back. Again, speakers, you can kind of get away with it, but there is actually very limited precedence effect on overhead. We have not evolved in such a way that we really rely on what's happening above us in terms of sound. And then, of course, the second thing to bear in mind, and these are all things that will really go towards how you mix things and how you record things, is the fact that we are dealing in ADM files, which are pretty huge, but of course, up to 128 objects, the first 10 of which is a bed. But of course, those get really kind of crunched down or quantized, if you like. So, for example, in the left image here, we can see the way that you have all these blue objects, which are within the sound field. On the right-hand side, you see once it goes through spatial coding, it gets dithered down and stuck together, so you go, oh, we're going to split it out into regions. So, and that's because you can have up to 128 objects, but at the end, when it's streaming, it's only going to be coming out of a maximum of 16 possible objects. And that also applies to all the game systems. Early game consoles were only 8. The more recent ones are 16 objects, and that includes Xbox, especially PS Labs. They've been putting a lot of effort into this kind of thing, but PC as well. Fmod, for example, already has ways of dealing with this part of it. So knowing that it's going to be stuck down like that means that you can have it gives you a good idea of how to treat the audio going forward. So creative uses of the differences of the binaural behavior between beds and objects, I think, is really, really key to look at. So I like, for example, segmenting the room into quadrants. So decorrelation of live mics is something which locks nicely into that. I'm going to explain each of these on further slides. Establishing beds within an ADM as an anchor to establish a sound rule. So, for example, if we are encoding mid, near, far, or off in the front and mid and far, if you then have something which breaks that rule in terms of audio, that can sound really, really cool. So if, for example, you have a very lush ambience, and then and that's set so it's mid and far, and then you've got a single object that's near, like a synthesized object or a voice again, that's running through space, you are using the anchor of the bed to really separate it out, which is very effective. And then, of course, I really do encourage you to worldize or reamp, if you like, audio, because one of the nice things about Atmos, of course, is in a standard stereo environment, it's there's limited use or limited kind of let me say not use, but reverbs. I think a lot of the time we go, okay, well, let's put a reverb on something and place it within there. Whereas if you have just even a pair of speakers in a basic room with a couple of microphones, you can really get a lot of early reflections, or the original term for early reflections being dimension, just by mixing even like basic mics. Even by mixing a couple of those elements in, you can get enormous differences when you're dealing with binaural encoding. So, for example, including bottom mics, there aren't bottom objects, but your brain can it realizes, okay, I can hear that because there's a source here and a source at the bottom, even though it's still in a 360 space and there aren't, technically speaking, objects down there, your brain is able to calculate that there's a difference. So it makes certain things feel higher and lower. So here we go. Creative use of different binaural behavior, establishing a room or a bed rule. As you can see on the left, we've kind of looking at it as a segmented cut-up kind of room. So even though it's a full room, it does, I think, a lot of the time work well to separate the room into these quadrants, including the top. So just like the earlier picture I showed you, you can go, oh, well, okay, great. We're going to maybe not have too many things clustered in this area. And then on the right-hand side, this is a very typical binaural bed setting that I use. If it's for post-production, you're probably going to have left, right, and center on near. But for music production, I personally prefer it to be off. But now that's established a rule, which means that we can break the rule. So over here, if you look on the left again, on the left side, you've got the lighter green. That should be, for example, if you take the green as the dimension of the room, the lighter green would be a more near or mid binaural encoding. And then the darker back of the room would be a more far binaural encoding. And then by having the red object that I mentioned earlier being near encoded, it really helps it stand out. And that's not something you would even really notice or you wouldn't notice at all on speaker playback, but on headphone playback, it helps separate that thing out. So with that in mind, a couple of things that I like to do is segment the rooms when it comes to recording for, say, film scores or game scores. I'm lucky enough that I get to work with a lot of orchestral composers. I'm going to show you a clip later, but this could be just in a basic studio or even in your basic room, and it doesn't have to be anything as elaborate as this. Even just having 2 or 3 microphones, just basic microphones, closer and to a source and further from a source, and then attaching those into an ADM such as this will really, really help create a sense of depth. So this, however, you can see is very much linked to the right column where you can see, okay, I understand why you've got Omni mics there. And I have treated the microphones not to try and get all the audio, but to likewise segment the audio into sections like I did in the previous slide. So for example, figure of 8 microphones on the side will reject things on the front, and we get more of the reflections or the off-axis sound, and then even more so for the supercardioids or hypercardioids on the rear. That's going to mean, okay, that part of the playback is really segmented away from the front. So and this all comes down to decorrelation. We want it to be different. So this is a kind of a more complete version of that. This, if you'd like to take a grab of that QR code, which I'll also post on the Discord later. This is something called Echo Project, which we're involved in with Air Studios, and there were 8 arrays where we experimenting with different ways of dealing with recording specifically for immersive, recording music for immersive projects such as games. Okay, so mix tips and tricks, in-the-box mix ideas, because you're probably thinking, well, this is great, but I don't have access to an orchestra. Once again, even if it's a harmonica, or if it's your voice, or if it's a single guitar, these things all work for that as well. Don't worry about it just being for larger recordings. But some things that are quite handy on the mix side is I mentioned object size decorrelation. Now, the nice thing about that is unlike in a bed or behavior in a non-binaural encoded environment, if you resize an object, it has the benefit of decorrelating around the channels very close by. Now, that may not seem like such a big deal, and in fact, generally speaking, I really avoid it because it can create a wash. But if you are trying to feature something, just resizing it briefly allows your brain to go, ooh, there's something tasty there. And the same thing for fast side panning. This is something which I very much picked up from Srijesh Nair, a colleague who works for Avid. And what he does is quite clever. If he's got a tactile interfaces, he takes the pan and he flips it to the tactile, and he just like touches it almost randomly every so often so that things on the side wall pan in very slightly just to catch your ear once again. Wide object effects buses are another good example. So if you've got a cascade of effects in the, and then you put them through a wide AUX or a wide bus, such as 706 or 906 or what have you, that is a really good way of then having discrete objects in the sound field. And then if you then have that inverted in some way, so for example, to a bed. So if you have a bed equivalent or another wide bus, let's just say that one's mid or far, and then you have the effects, the delays and things like that near. Again, it creates that tension, it breaks the illusion. So for example, an FX matrix would hit your ear quite differently, such as this one. Over here, starting with the crystallizer and ending with the filter freak, we have just a selection of plugins that I like to use to create stutter effects. And this is a good example of, okay, great, I've now taken something like this and I've placed it into a different binaural environment to the source. So it will immediately stand out. And again, these are all things that help make, in my opinion, the mix not sound like a total soup when you're trying to squeeze a lot of content into just left and right headphones. What to avoid? Things that are great on speakers but kind of suck on headphones. Again, rear placement has very poor fidelity. So right behind you, we had in this echo thing, we had an example which was a really, I'm glad we did it, but because of the way the recording was done, the piano was in the rear. And it honestly just sounded like it was in the front, but with a really like not great high EQ that just rolled off. Because of course, that's how HRTF works. It's going to adjust for the back of your head. Your brain just isn't good on headphone based playback at figuring that out. Back to front. Another one would be mid-stage panning is poorly represented. right down the middle, it doesn't sound great. It just sounds like it's mono, but just a different kind of EQ mono, if you like. And it's even worse on the overheads. So that's why it's generally a good idea to be sticking to the walls when you're panning as much as possible. And of course, I mentioned issues of precedence and locality. Your brain can't pick up something exactly where it is. There's a reason why when there's an ambulance behind you that you have to tilt your head around to figure out where it's coming from when you're driving somewhere. So if you'd like to take a screen grab of this one, this is a proof of concept mix I did for a master's I was doing a while ago. This was a film I had actually previously worked on. Funny enough, it was also, this ended up being on the list of Beyonce's references for Cowboy Carter, a South African language film. And if you'd like to take a screen grab of that, it'll link you to a kind of a proof of concept mix to see how far I could push the synths. Trying to figure out what is and isn't in good taste, if that makes sense. It's part of the research I was doing. And then for this one, I'm going to play this one for you now quickly. This is a game score in stereo and Atmos. This is from the game Guild Wars 2. This was the 4th X-Pack. I've been lucky enough to be working with these guys for the last 4 years. They were, especially on the PC side, one of the earlier games to really go in for the object-based and Atmos music side of things, which was really a lot of fun. So I was very, very lucky to be working with them for the last 4 years now. So yeah, I'm just going to I'm going to kill this presentation, swap to my renderer, and we'll give it a quick listen. And what I'm going to do is I'm going to start it in stereo, and I'm going to swap between just the straight up stereo version and the binaural version. Okay, please tell me if you can hear. Did you guys get that? Okay, great. Here we go. Going back to binaural. There we go. I think hopefully you can hear, especially on things like the stutter effects and the voices in particular. And also the surprising thing for me is the low end, how much bigger the low end is. It's if you'd like to do some ABs of your own, if you want to grab that QR code again, I will also put that in the Discord as well. I'll just play the end so I don't have OCD. There we go. I hope that was fun, and thank you so much for attending. Really appreciate it. Thank you very much. I hope I was okay for time.
Fantastic. Thank you, Simon. Really, really good. Thank you very much indeed. We're very much appreciative of you being here. I'm going to send you back to the backstage now. What we're thinking is, because we're a little bit over time, we may run into the next session now and then hold Q&A until after that session, just because otherwise I've got to delay everyone by 10 minutes to bring you all back again. So just rather than get out of sync, I think we'll run the next session now, and then we'll do the Q&A for all of the prior sessions at 3:40 UTC. So that will be in 40 minutes from now.
Well, thank you so much.
No problem. Thank you. I'm going to push you back to the backstage, and then we're going to move straight into our next session. So the next session is from Julius Smith, and Julius is not actually with us at the moment. I believe he may have got his time zone slightly confused. Hopefully he will join us for Q&A at the end. He did say he would be around, but his session is a pre-record, so we're going to play that in now. He should be online to then engage at some point during the session. We'll go and chase him now. But yeah, we're going to roll the video straight away. So I'm going to cue the video now.
Greetings, welcome to the talk, Python templates for neural image classification and spectral audio processing, part 1, Lightning Hydra template extended. So what is all this? Well, the Lightning Hydra template is something a lot of people use to get started with their machine learning projects in PyTorch. And it has a little example for image processing and image classification. So I got inspired by that and decided to add on to it and just learn a lot about image processing that way, because ultimately I want to do spectrum processing. I want to do spectrograms to parameters of various types. So so this is the extended template. Started with a fork, and then what it does natively is gives you your Hydra support, gives you PyTorch, the Lightning wrappers for your modules to help make them a little more easy to train and to work with. So there's just a lot of conveniences there. It's very well used. The chatbots know it really well. That really is a huge advantage I didn't expect. They really know how to get around in it and never get confused, unlike my other code bases. So the LHT Lightning Hydra template comes with a multi-layer perceptron trained on MNIST. Just a very simple little example just to show you how everything works. And it trains up and it gets state-of-the-art results, and it's really exciting. It's just a little network that works really well on handwritten digits. It's a standard data set for that. So what's happening in the extended version, LHTE, is we're adding CNNs, Vision Transformer, ConvNext, which is sort of the CNN answer to Vision Transformer or to transformers in general. It incorporates a lot of the ideas and does really well. And then EfficientNet, which is really good for small systems, like if you're going for a phone or something like that. And there's also more dataset support. So in addition to MNIST, we have SciFar 10 and SciFar 100, and I have some previews about that. And then a new one I'm calling VEMSH. It's like hyperbolic sine is pronounced cinch. So this is the variable image multi-head format, and it's basically a generalization of SciFar 100. And so you can have up to 65,000 by 65,000 images, and each image can have up to 65,000 channels. So that's RGB and whatever else. But in my way of thinking, it's, alternate spectral representations. So you can put alternate time frequency resolutions. In those planes, you can do modulation spectra, instantaneous frequency, instantaneous delay. There's a lot of things to try there that might help the network learn a little more efficiently. And so it's also got multi-head support. So that means there's a shared network, and then it splits out into separate classification heads. And those are 8-bit labels and 8-bit values. So up to 256 heads and 256 logits coming out of each one. And so where I'm heading with this is synthesis parameters. So spectrogram to synthesis parameters. And so these limits have not been binding and probably will not be. I'm limited to 256 parameters, and I'm at half that right now in physical modeling. And then each one has, up to 256 actual settings. So the knob can only have 256 clicks, and that's the number of logits in the classification case. But I also support regression, just plain regression, numerical interpretation of the knob. So comparing those, actually right now regression is winning. So I might not even use classification in the end, but other people, things I read about, other people are getting better results with classification over regression. And there's a bit of a story there. So anyway, everything has data loader support, and the model architectures know how to read the various data sets. And so there's an experiments directory, which has a lot of, nicely frozen examples, including benchmark replications. And so, for example, SciFar data sets are very well known. I mean, there've been a lot of competitions. It's like 15 years old or something. It is, in the 2000s that they were really working on this stuff, and that's why it runs really fast right now. And you get small networks by today's standards. But the great thing about being able to replicate those benchmarks is that you know that you don't have a bug. So you ingest these architectures, which I did using Claude. I found the best code I could find on the web, and then I told Claude to integrate it into this template environment, into the Lightning environment, and it did it. And you need to be able to test it, right? And so if you can replicate these benchmarks, you're doing quite well. You trust your integration pretty well. All right, and I like make files, so there's 80 make targets for testing and training experiments, so you never have to type very much. It's also actually, I find, very convenient for sending a chatbot off to go debug. You just say, please debug make T, and it'll go run your tests and find the bug and reproduce it and fix it. So first, a little bit on the original Lightning Hydra template. It's free on the web, of course, and it's a template. And so it's a skeleton with a source directory, a configuration, that's Hydra configuration, and a test directory. That's your basic PyTest stuff. And there's also under configs, there's your experiments directory, and that's an important one. And and chatbots really love it. They've seen a lot of this, and they know how to get around in it. And that was an unexpected dividend of being in this framework. And so the Hydra workflow is really nice. You can override, so you can run Python on your train script and then override the there's a default case in there, and then you can override the default, say, I want the GPU, I want to change the bat size. And so this is a config file with a data, struct, I think of it, and then it has a field, which is batch size, and you can just override all these things from the command line. Very convenient. And the chatbots really know how to do with this. So they'll run experiments for you. They'll just make lines like this in order to try things out. So they're very, very fluid with it. And so there's a lot of possibilities here. And so let's see. So the original LHT just had MNIST MLP, and so now we have more, and that's the basic idea. So if you want more image processing stuff, this is a good place to start. And as I said, I'm using it for spectrogram signal processing of various kinds. And so another thing is that all the extensions are backward compatible, so you can still run the original MNIST MLP experiment, and that's in there. So you shouldn't have any problems if you've been using that template before. You should be able to move to this without breaking anything. So as I mentioned, the data sets have now been extended to SciFar and VIMSH. And so SciFar 10 is this little 32 by 32 RGB. So MNIST is 28 by 28 grayscale. And so you only have 10 classes here. And so, as I said, if you reference it, then you'll automatically download it. And there's 50,000 training, 10,000 tests. And so, so there are these, you can run these examples and get CNN 85 to 92% accuracy, Vision Transformer, Comp Next. So this tells you what to expect when you run the benchmarks. And here's how you might run a benchmark, using the makefile. You can, I have all these abbreviations. So let me just show you quickly how I run these things. So, so you can say make help and you can just abbreviate that H, and I'm in the wrong directory. Make H, and there it is. There's all the stuff. And if you just want to know for example, I had this little thing, make help grep. And so I can say make help grep. What do we want to do? Everything to do with SciFar. And so there's all so you can pick out one of the benchmarks there. And of course, there's a README that will get you started. And I like to view that in Cursor. It's got a nice markdown previewer, from the VS Code world. So that's just kind of how you get it up and running. You just explore the make targets and see what they're doing, and get your chatbot to explain everything to you. So there is an example of some of the images. All 10 classes are right there, in fact. And see, within each class, you'll have, a large number, I guess 5,000 roughly. So that's kind of the workflow and how it looks, and you can verify it and feel pretty confident about it. And then we also have SciFar 100, and so that's now got 20 categories, and they're considered coarse super classes, and then 100 fine classes. And so I'm using that basic idea to map it to the synth matching problem, where I have, in my case, it would be like 20 synthesis parameters with 100 settings on each knob, that kind of thing. So I want to kind of, leverage this long-standing image classification research to, see if it can help me with my problem. And I'm, comparing a lot of things, comparing Vision Transformer to CNN and seeing what works best and what's lean and mean and runs fast. It'd be nice if it runs in real time, right? And so, so here are some of the benchmarks. And so I've got multi-head as well. And so here's how you would run, for example, the SciFar benchmark, SciFar 100, using CNN. And so you can also spell that out in more details. And you should see somewhere in this range of accuracy. And, you can look at it in TensorBoard and see if it's really done. I might not run quite long enough to get you that high, but you should get close. So that's the basic idea. Oh, and this one will run all of the benchmarks. So the entire suite of benchmarks, make SciFar benchmark suite, SciFar 100. So that's how you can run all these things and test them out. Okay, so that's SciFar 10, SciFar 100, and then the other data set we have is VIMSH, variable image multi-head. And so here's how I'm using it, not in this project. This is from another project that's in part 2, my next talk, I'll say. And so the images are spectrograms. And here's the input spectrogram. Here's synthesis from the parameters in the data set. This is predicted. So the neural net came up with these parameters and synthesized this. And this is actually an overlay of the true waveform and the original waveform. And this is a sawtooth through a wah pedal. So there's a decay time and there's a wah position, and it just nailed it. So it's just really working. This is my, version of the MNIST MLP that came with LHT. So LHTE extends that, and then in my next project you'll have neural spectral modeling template. Okay, so these are the things I said before, the size of it, flexible labels, and it's self-describing. So the data set tells the architectures what's there, and so everything adjusts to the data. So if you want to change your spectral dimensions, you can. All these channels have to be stacked up at the same, height times width. And so so they're all the same in that sense. So that's kind of the architectural prior, so to speak. And so I just showed you how you can do make help, and you can grep for something. And so yeah, we can just let's do a make help grep for VIMSH, and you can see what the targets are. So you see there's a number of them here. You can also do diagrams. So let's look for diagrams, and you'll see a number of things you can do. So let's make TDA, that's text diagrams for all architectures. And so it makes these nice text diagrams. They're really cool because you can you can see what you have, what you're using. There's two formulas. There's kind of a Lisp-like, I guess that's Python syntax for the whole thing. And then you have these nice block diagrams. And I think that's good enough, All right, so those are the new data sets, the new architecture, and now the new architecture. So CNN, this is classic stuff. Don't need to spend a lot of time on this. But this is an automatically generated diagram from Claude. It just went through, I gave it that text diagram actually, and it did me a nice little figure here. It's something. And so here are the kinds of things you have. Just two convolutional neural network layers, and this is classic CNN stuff. So for CIFAR 10, you should see 85 to 92%, CIFAR 100, 55 to 70. And so the experiments that are here have, a small 8K neural net, 68K and 421K. And we saw 1.2 million for, the next project. So these are all down in the million or less range. And they do very well. And the reason you can get away with something this small is because, it's only 32 by 32 by 3. It's a very, very small input. And but of course, the classification challenge is quite difficult. So in spectrogram recognition, it's not so bad. And in a well-conditioned spectrogram can do well at 32 by 32. I'm getting good results at that size. So as I said, we added multi-head classification and regression. So these are the architecture config files, and it's not as bad. So we got all the CIFAR 10, all the CIFAR 100, all the MNIST, and we have three sizes, usually 64, 128, and 210. So, you have just kind of a smattering. Here are your vision transformers, efficient net, ConvNext. And so these are just the ones that I developed because I wanted to try them out, right? And why not just leave them around? And so they're all there. And then, of course, the LHT has exactly this one, just example.yaml. And that got me off and running. And so, I don't claim all these are well tuned, but some of them are. Some of them are tuned up to replicate benchmarks. And so they're gonna give you really good results for those benchmarks. But you'll have to, have your favorite chatbot tune up yours the way you want it. Here's ConvNext, and you can read the paper. It's the response to vision transformer in the CNN world. Here's EfficientNet I mentioned. Here's vision transformer. And I've only got a minute, so I'm just going to breeze past these. It's all super standard stuff, but it's good state-of-the-art stuff. These things are not obsolete. Transformer does not make any of this stuff go away. Well, Transformer is used in vision transformer, but CNN still when the translation invariance is a reasonable assumption when you can get by with that. And here's a diagram of the multi-head classification. You have shared features and you break it out. And these are either classification heads or regression heads. You have both. And so there's that. So then finally, there's this just kind of a little bit about the workflow here. You got the experiments. I showed you some of the architecture files and how to get around using make a lot. Don't type too much. And then yeah, we covered that pretty well. Here are all the experiments at the moment, and it's got some benchmarks and some regression stuff. So that's about it. And the next steps are, merge PRs and every time a new chatbot comes out, I'm going to have it go through everything, see if it can suggest improvements, and that's about it. And here's a summary of all the. So this is the original Lightning Hydra template, and here is the extended version. And here's what I'm going to talk about next, and that is the neural spectral modeling template. It's just a fork of this, And here's my homepage. I'll have links to everything there, the video that comes out from ADC and so on. All right, that's it. And I'm only 1 minute over. So I'll go on to the next talk. Welcome to Python templates for neural image classification and spectral audio signal processing. This is on the neural spectral modeling template. So it's just a fork of the Lightning Hydra template extended, and it's aiming specifically at audio spectrogram. So we're now introducing audio into the situation, and we're also taking out SciFar and MNIST and just having VIMPSH for the data set. So the philosophy here is that every image is some kind of spectral representation. The height is frequency in bins, and the width is time frames, your basic spectrogram layout. And we also have these channels, which are interesting. So you can just think of what other, the classic is alternate time frequency resolution. So, short windows, long windows, the time frequency resolution trade-off that the ear has to commit to, having, high resolution at low frequencies and low frequency resolution at high frequencies. Instead of making that trade-off, you can just have them all. And we have had projects at Karma that have shown that you can get good results with that multi-resolution where all resolutions are available for estimation. So it's a known good thing to do. And then there are other representations like instantaneous frequency, group delay maps, modulation spectra are known to be very valuable. You may have heard of joint time frequency scattering. Professor Malat and others have firmly demonstrated that that's a good thing. And I would say McDermott at MIT has demonstrated that that's an important aspect of spectral texture perception. So we can put some modulation spectrum in there. And anything we know of that might help the network to learn can go in a plane, and the network can ignore it or it can use it. So we want fast, accurate, small neural networks, and we're going to commit to the fact that it's human hearing. So that's the reason we're using CNNs. That's the reason we have spectrograms. And so CNNs are very efficient. They're the winner in my experiment so far. These are small systems we're going for, lean, mean signal processing for audio in your phone or whatever. And so we're only going to use VIMPSH, no MNIST, no SciFar. And so I just thought I would say my usual thing about why are we not doing things end to end? The end to end people would say, well, no, you should just a bit stream is enough. Don't even tell it what the word boundaries are. Just let the network figure it out. If it wants to know where the words are, it'll figure it out. So it's really a lot more work, and I've convinced myself of this. If you know you're doing audio, you'll be much better off with helping the network. Tee up whatever you can and let it learn what it has to learn for you beyond that. And textures are where it really does well. So it's I like to give it everything but the texture and let it finally classify the texture. And it's fine to think of it as an image as far as I can tell, or and also modulations. So additionally, there's conditioning inputs. And this is how you do things like bring in explicit pitch, explicit, the original DDSP had pitch as an external input. It was, a different network that computed that. Decay time, I'm finding good results by measuring it myself and then bring that in as a conditioning variable. And one reason for it is that, in a CNN, you're supposed to be translation invariant. Well, a decaying signal, if the signal's decaying slowly over the whole image, then that's not translation invariant, and the CNN can handle it, but the basic structure of convolutions that slide through the image just aren't as well matched as they are when the features are small compared to a convolution kernel. So, or on that order. So that's something that I find you can sort of help your architecture. You're committing to this translation invariant image kind of processing, but then you can bring features in on the side that violate that assumption. And a preemphasis is another one. That's where you you flatten the spectra, so you can flatten the spectrum and then bring in the preemphasis coefficient and bring it in as an embedding, and then it'll work that in. And so it knows everything that's going on. It just didn't have to measure something that's a little bit harder for it to measure. So, and I have not completely proven that these conditioning variables are definitely helping very much. In one case, it definitely helped, and in another case, it did not help. So I've got to put more effort into proving that it's definitely a good thing always. Let's say that's research in progress. So this is, I think, a good example of how you want to think about it. You've got human audio here, so you might as well just give it an ear. Don't reinvent the ear. Don't make it learn the ear. You give it an ear, and then you go through your basic CNN, and this is some work by Kell et al., where they were able to get human level performance on word classification and music genre classification, and sharing a lot of the network, and then having a multi-head extension. And so the multi-head extension I have just has a final linear layer, and that's your final classifier, and it can go through a softmax, or it can go to just a regression head. So they were able to show that you needed this couplogram input to get correspondence to the brain, and they were able to predict cortical responses from their network. And it was just an interesting exercise in how much do you really want this. And when they took it away, the whole system was very alien. The kinds of mistakes that it made were very alien and not human-like. And so if you want it to be like human hearing, then you can really help it by forcing it to work with a spectrogram, a cochleogram in their case, which is like a very accurate auditory spectrogram. So we're doing that, and we're also doing the multi-resolution stacks. So instead of just one spectrogram here, we have a whole stack of them, alternate spectral representations. And as I mentioned, we've got these conditioning inputs where you can measure other features and bring them in. And they tend to come into this final layer. So they go through, I think it's an MLP, and then just inject in. So there's a lot of ways you can bring in conditioning. And okay, so this is just what it looks like to inspect the data set, and you can step through the data. And I have this live over here. Where is it? It is this thing. So this is it. Now I can step through the data. And so what we're looking at is a very simple synth matching example where we have a wah pedal, and we have a sawtooth synthesis, waveform synthesis, and we have a decay pedal. So the only two parameters are the wah setting and the decay time. And so those are, so you can see the wah pedal jumping around. You can kind of see the decay. And on the other tab, you can see this in the so-called waterfall diagram. You can see the whole thing. And the nice thing about these is that you can move them around. And the chatbots are really good at making these kinds of tools, by the way. So we're just going through the data here. And if you have different channels, you can use the down arrow and go through the channels and see all the representations. And then there's a third tab that actually shows the audio. And here's where you really need to be able to pick it up. Now you can see that it's a sawtooth through a bandpass filter. The wah pedal is a bandpass. And you can see the decay through time. So this is just allowing you to step through your data set and see all the samples. And the parameters are here. There's a set of fixed parameters, and there's all your variable parameters. And you can step through them and get an idea. And these are all synthesized, of course, right? And so that's why everything's so precise, pristine. And that's audio specific, right? So that's not going to be in the LHTE. And so this is just taking you through some examples of what I just showed you. So now for the workflow, you have make targets for things like synthesizing a data set, like the one I just showed you. And everything's configured by Hydra configuration files. You can override them at the command line and so on. And so there are make targets for training a CNN or a vision transformer. You can override them and say, I want the small ordinal, that's the loss function, ordinal loss, and I want my trainer to stop after 50 epochs. So that's the kind of workflow with Hydra. So normally you just say Python train.py experiment equals some YAML file, and that is your that's all your specs, and that will be very repeatable. I always set my seed so I can get exactly the same results. And so all the checkpoints come out, standard machine learning stuff. I've been using TensorBoard. You can use weights and biases. And so that's all very convenient. there's also an eval script that goes all the way back to the Lightning Hydra template, and it's also in the LHDE. It's inherited from that, in fact, and so you can do that. But I wrote a different one called Audio Reconstruction Eval because it's very specific to my situation, and that thing will get the latest run or the run that you specify, and what it does is it takes the spectrogram, runs it through the model, gets the estimated parameters, and then synthesizes it. It has the same synthesizer, it's the same utilities, and then it creates the audio from the estimated parameters and it compares it to the ground truth. And so that's the problem that I'm working on right now, which is, we call it synth matching, and quite a bit of research on it, a lot of papers on this. And so this is what it looks like, and I can run that in real time as well. Of course, I have a make alias for that. And so here it is. And so now we can step through the data samples, and you can see that the overlays are really good. There's two different colors, but as you can see, the input spectrogram, the synthesis from true parameters, and the synthesis from predicted parameters, and here are the parameters themselves. And the extent to which these two bars are the same, it's nailed the problem. And these are some metrics. You can see that it's doing very well. So it's just really nailing this. And so you can see that it's about 1.1 million parameters. It's a very simple CNN, 1.1 million. And so that's good enough to solve this problem. But, it's just two parameters, but they're not specifically, they're not using conditioning. So, the CNN had to be able to deal with that much of a non-translation invariant, spectral tilt. And so, it's kind of it's two worst case parameters, perhaps. It's not the kind of little textures that they like to classify and build on hierarchically. So that's how that goes. So there you have it. That's the evaluator. And let's get back to the presentation. All right. So, and also when you're trying to get it to train, you look at something like TensorBoard. And so this would be then the mean absolute error, I think it is. And this is for the decay time, and this is for the position of the wah pedal. And one thing to point out here is that it's very important to define your synthesis parameters in perceptual units to the greatest extent, and bracket them over the range that you actually practically plan to use. And this is kind of an aside on synth matching, I guess you would say. And so this is the log 10 of the decay time, and it just varies over the range that I really want to use. And the wah position, I'm just assuming that the wah variable has been calibrated to exactly the right thing, so that 1 degree of change in the pedal angle is 1 perceptual unit or whatever, and so that's basically just ready to go. But you have to calibrate. Sometimes you have to take a log. Sometimes you might want some nonlinear perceptual transformation. And so you can see that this trained up really well after just 5,000 steps. It was basically really close. So this is a very smooth training. And this is, of course, all synthetic. Next steps are, I'm going to add noise. I'm going to, try to get it to generalize, and ultimately try to get it robust at approximating any sound you give it, and get the best approximation. And so in the time I had left, I thought I'd talk a little bit about the loss functions. I did a little bit of explorations of loss functions. So the first one that just kind of came with LHT is the cross entropy loss. And that was good for our classification. But, I thought about it and realized, well, we'd like to, realize that our logits are, settings of a knob. And really, you just want to be at the peak or near the peak, and so you get into things like soft targets and weighting the distance from the truth. And so the weighted cross entropy loss does that. It adds a absolute bend distance to the alpha penalty, and so that's in there. Here's the soft targets thing, where you basically, so you want this setting for the knob, and you just basically convolve that with a triangle or a little Gaussian or a log triangle, and it basically just spreads it out. And so now a cross entropy will not be all or nothing. You don't have to line up exactly, so you get partial credit if you're nearby. Then that's in classification. Here's another kind of, it's kind of in between classification and regression. It's called ordinal regression. And so basically the softmax goes into a weighted average prediction, and you want the loss to be in perceptual units. This is, again, comes back to your parameters being ticking so there's a min and a max and a step, and the step should be like a just noticeable difference, or they should all be two just noticeable differences, that kind of a thing. And then everything will be calibrated to minimize perceptually. And then there's the quantized regression loss. That one's a scalar output over quantized steps. And so it scales the L1, L2 Huber loss by the data set step size. And then finally, we have regression. And that's just pure regression. There's no logits. You just, are estimating a parameter value as a floating point number, and it's normalized to 0 and 1. And so 0 is your min, 1 is your max, and you get to use a sigmoid during training, which is nice. So you get a nice differentiable limiting. This is probably standard. Everybody probably does this by now. So that's really a nice, robust system. And this is the one that's winning at the moment. This is the one that's it's the current default. I'm getting the best results with this very, very simple, pure regression. But as I mentioned previously, I was able to get better results using classification and auxiliary input, conditioning inputs. And of course, you can add your own. So there's this file here, losses.py. You can add anything you want. So future work, merge PRs, chatbot reviews. Every time there's a new chatbot, stick it on the whole code base, make it better. Check it though, look at those diffs. And I'm going to add, I would like to add RNNs. These are all, CNN and Vision Transformer and MLP. I'd like to have some RNNs. I'd like to have some diffusion experience. I want to work with that a little bit. And I still have yet to put in the multi-scale time frequency stuff, the modulation spectra. How much do they help? Do they help? One thing I can tell you is that the modulation spectra do help. There's a recent thesis by Han, and you can find that. And it very clearly and convincingly shows that with the joint time frequency scattering, you get a much better result in the synth matching problem. So I'll just leave it at that. I'm out of time. So I guess it's time for questions.
All righty. Well, thank you very, very much to Julius. I believe Julius is going to join now over in Gather if you do have any questions for him. So he should be just joining in over there at the moment. So otherwise here, we're going to now go to another break. So this is going to be our longer break. If you're joining us in Gather and the virtual venue, we're going to now have a number of meetups that are taking place at 4 o'clock UTC. So in just a few minutes' time. Otherwise, there's a break period before that where you can go and explore our virtual venue, meet up with some of our community sponsors and partners who are in the Bristol space. I urge you very much to go and have a look around. There's some really cool spaces, particularly look at there's a new space in the bottom lower left of the map, the Thekla boat. That's worth investigating if you haven't been there. We've also got the Pit Pervasive Media Studio in the bottom right-hand corner. We've got Dynamic Cast, we've got YSWN, we've got Sound Without Sight, we've got Sound Girls in a building there as well. We've got the Interactive Audio Special Interest Group, and also the Immersive Audio Network. And who else have I missed? Let me just have a look. Dynamic Cast. Oh, and SoundMit, of course. We've got SoundMit and ADCx India as well that you can go and explore. So the next sessions will start again here in the stream and in Zoom at 1640 UTC. Otherwise, we've got the three meetups taking place now at 1600. Okay, thank you all, and we'll see you back here in a little bit. Righty, hello everybody, and welcome back to the second part of ADCx Gather 2025. If you're just rejoining us from earlier, welcome back. If you're joining us for the first time on YouTube or just joining to the virtual venue for your first time now, welcome. Please take a look around the virtual space. We've got lots for you to see, and there's still some more content coming, including another poster session and our quiz at the end of the day, which also takes place exclusively in Gather. If you haven't and you would like to join us in the virtual venue, there is a form in the YouTube chat, if you're watching there, that you can use to fill in and join us in Gather. Otherwise, we're about to start the next talk and the next block of talks. So our next speaker is Will Anderson. Now, Will is actually a veteran volunteer for the ADC organisation and the various previous events that we've had, I think for the last 3 years or so now. He's a well-known face that you may recognise from your previous ADCx Gather or even the ADC 2024 conference last year. So it's wonderful to have one of our volunteers become a speaker. So sadly, Will isn't here. He's actually on holiday this week, but he will be joining us on the Discord to answer any questions. So he's joining remotely that way. He won't be in Gather or here in Zoom, but we're now going to play the pre-record. So Will is talking about free-range users make for more profitable doors, why doors should prioritize interchange formats. So over to Will.
Hello! Thank you very much for coming to my talk about DAW interchange formats and the benefits of free-range users. My name is Will, and I've been a classical sound engineer for a little over a decade. So while I'm not qualified to talk to you about niche C++ concepts, I do feel qualified to talk to you about using DAWs day in and day out. Now, I wouldn't be here if I didn't also do some programming, and throughout my 10 years of putting microphones in front of people, I've also written a variety of internal tools and designed hardware units to aid in efficient production and post-production for classical recordings. And more recently, I've been turning one of those tools into a commercial product. It's through designing post-production workflows and the development of some of these internal tools that I've come to spend quite a lot of time with DAW interchange formats. The rest of this talk won't make much sense unless you're familiar with what a DAW interchange format is. Essentially, it's a text file that a user can export which describes everything they've done in their project in DAW-A, and they can then import that file into DAW-B, and as if by magic, the second DAW will reflect the work that they did in the first DAW. This enables users to mix and match DAWs for different parts of their workflow. These users who aren't locked into a single DAW to complete their whole project are what I call free-range users. They're able to freely roam and choose what's best for them at any given moment in their workflow. Mechanisms to transfer projects between DAWs have been around for a very long time. Historically, they've been set up to deal primarily with the exact position of audio on the timeline, alongside basic mixer settings and automation. Some more recent formats also include information about plugins and plugin states, and have support for MIDI data. To understand this a bit better, we'll have a very quick look at 3 interchange formats, ranging from one that was released a few decades ago to one that was released just a couple of years ago. CMX EDL was originally released in the early 1970s as a way to transfer data between nonlinear video editors. It's very much geared towards translating the exact position of media clips on a timeline. It's a basic text-based format which describes the SMPTE timecode of events, so all these timings are accurate down to a frame. Some DAWs also integrate it as a method for both transferring an audio edit from your DAW to a nonlinear video editor, but also for transferring edits between DAWs. As you can see, the important elements are the name of the clip, the start and end positions on your timeline, and the start and end positions within the file, with respect to that file's internal timecode. It's very straightforward and pretty good if you're doing a rough comp in one DAW and you want to transfer that to another DAW or nonlinear video editor. But because it was designed with video editors in mind, it doesn't transfer other data that we might want in the audio world, like accurate crossfades or any mixer data, and it's only guaranteed to transfer data for the first 4 tracks of your timeline. That brings us to AES31. This format was released in 2001 and was primarily adopted by specialist classical DAWs like Sadie and Pyramix. Like CMX EDL, it describes the position of different clips on the timeline, but it takes things a few steps further. It increases the accuracy of all timings down to the audio sample. So rather than, say, a 30th of a second for a CMX EDL, you're looking at perhaps 1/48,000th of a second for AES31. It describes crossfades not only in length, but in shape. It implements some transfer of mixers by describing fader positions, pan values, and mute states. It provides a list of all the audio clips used in the project and where to find them on the hard drive. It contains loads of metadata information about the project, including the sample rate, and it can handle any number of audio tracks. This is obviously a big improvement, and the extremely accurate description of crossfades and clip positioning made it ideal for classical DAWs. However, the lack of support for describing plugins and MIDI files hampered its adoption in mainstream pop DAWs. As far as I'm aware, Bitwig's DAW project is the latest interchange format to be released. Having been released in 2023, it aims to be a more complete DAW interchange format. It's an XML-based solution and has support for MIDI files, markers, and even track colors, and crucially, plugins and plugin states. It leaves out some of the really accurate crossfade descriptions from AES31, but it adds elements that are more widely important. So, now you're incredibly well aware of what a DAW interchange format is, why should you care? On the face of it, doesn't it seem like allowing your users to transfer out of your software is a bad idea? Because then they won't remain in your ecosystem and might find a competitor's product that they prefer and then you'll lose out on money? I would argue the opposite. Let's pretend we are on the team at the fictional DAW WAD, Will's awesome DAW. We are well known for being fantastic for tracking. We've got absolutely rock solid uptime, internal latency down to almost nothing, and brilliant on-the-fly comping. But because we've poured so much of our time and resources into that, our mixing capabilities don't quite stack up against our competition, or at least don't match up for some subset of our users. Maybe we're great for basic audio mixing, but we don't have proper clip gain, our MIDI editing's a bit clunky or bug-prone, and our plugin parameter automation leaves something to be desired. If we at WAD decide that we're not going to think about a DAW interchange format as part of our core product, then the only users who are fully able to use our product are those who aren't worried about mixing and MIDI editing. Alternatively, what happens if we add a DAW interchange format? Those people who would have previously felt unable to use our DAW at all because it doesn't fit all their needs, well, they're able to use WAD for what it's best at, before transferring the project to another DAW to do the parts of their project that they would find frustrating to do in WAD. Now, that isn't to say that we shouldn't try to improve our DAW. Obviously, that's the aim. But anyone who's spent time really using a DAW will know that no DAW can be all things to all people. Every DAW has its pros and cons. With a DAW interchange format, we'd make it possible for people to use our DAW for its pros without needing to deal with its cons. The users who were already using our product and were happy with it will stay, but we make it possible for more people to use our product for part of their project. Essentially, if users are able to move in and out of our DAW freely, making them free-range users, we make it possible for more people to use our product to solve aspects of their workflow. And that is the crux of my argument. More users, more profit. I believe that the additional development time cost of adding a DAW interchange import and export option to WAD would be eclipsed by the additional revenue from more people being able to use the software. The only instance in which this doesn't work is if the entire unique selling point of your DAW is that you are the industry standard. But frankly, I don't think that's a good enough USP, and certainly not one that we should be trying to emulate. We should be trying to build a DAW that people want to use, rather than one they are forced to use. Enabling your clients to be free-range users also opens the gates for the users themselves to build solutions for niche workflows. Sometimes people will share those things with the world, and suddenly even more people view your product as viable for them. This point is probably less commercially focused than what I've been talking about up until now, but I suspect everyone here can understand wanting to be able to build your own solutions to niche problems. That's part of the beauty of the Audio Developers Conference, isn't it? Everyone here is both a creative and the sort of person who has the skills to write some software of their own, even if it's only for internal use. Sound engineering has a rich history of people building their own stuff to fix issues. Decca is still using bits of hardware that a sound engineer made 40 years ago because it solved a problem they had with TalkBack, and that proud tradition continues today. I see DAW interchange formats as another opportunity for that to happen. Unfortunately, poorly implemented DAW interchange import and export is common and can be worse than no interchange format at all. This often seems to come as a result of DAW interchange formats being added as an afterthought. At WAD, we are of course keen to learn from the mistakes of others, so we're going to look at a couple of real-world examples of issues in implementations of DAW interchange formats, and make some suggestions for what the team at WAD could do to avoid those sorts of issues in our work. So, to be clear, these are issues that I've actually come across when I've been working with AES31 and Final Cut Pro XML exports when building my own software. So, while the next section is technically entitled Real World Issues, the Moan Zone would also be an acceptable title. The first issue isn't too egregious, but it increases the barrier to entry and difficulty of use unnecessarily. The AES31 standard specifies that the audio files used must be WAV files, and as such, most DAWs will export a set of audio files alongside the AES31 text file. This can be handy if you originally recorded in a different format, like Pyramix's PMF audio files. In Sadie, you can either export the AES31 text file with this set of WAV files, or just the AES31 text file on its own. Or at least it says you can. Unfortunately, the export without media function is broken, and has been for over a decade. This means that you're left with no choice but to export all the audio files, which doubles the hard drive space required, and means that the export process takes much longer, as you're writing gigabytes to disk rather than just kilobytes. It's a simple fix, but one that has never been attended to. A suggestion for WAD? Well, if we're implementing quality of life functions, we need to make sure they work. We should also make it easy for our users to report bugs, and we should make sure that we have a system in place for dealing with those bugs. This next one is much more egregious, and makes the AES31 export and import functions in Pyramix completely useless in many cases. For context, classical audio people love high sample rates. Whether it's placebo or not is not the topic of this talk, but it's not uncommon to see classical recordings made at 192 kHz, and sometimes even higher than that. The issue with Pyramix's AES31 export comes at sample rates of above 96 kHz, so we're going to use 192K as our example. If you look at an AES31 export from Pyramix for a 192 kHz project, you'll notice two strange things. First is that the sample rate flag in the project metadata section states 44.1K rather than 192K. And the second is that every single timestamp is wrong, by a lot. In fact, it turns out that every timecode is out by a factor of 4.35 roughly. Those of you whose mental maths is better than mine might have already figured out that that is the exact ratio of 192 to 44.1. What's happening is that Pyramix is storing all the timing data for each clip as a number of audio samples, which is a perfectly sensible thing to do, given that that is the resolution it needs to report them at. What's not sensible is that it is then taking the number of samples in a 192 kHz sample rate piece of audio and converting it to a SMPTE timecode using 44.1 kHz logic. This means that a clip of audio placed 1 hour into your timeline will instead look like it's placed roughly 4 hours, 21 minutes and 13 seconds in. This non-standard behavior does 4 importantly terrible things. 1. You can't export a 192 kHz project from Pyramix and open it in another DAW because all the timings are wrong. 2. It means you can't import an exported file from another DAW for a 192 kHz project because the import logic is faulty. In fact, on import it multiplies all the timings by 44.1 times 2 divided by 48. I don't fully get that one. 3. You can't import a 192 kHz AES31 file created in Pyramix back into Pyramix. And 4. Due to our old programming friend overflows, if there is any data that should be a number greater than 5 hours, 30 minutes and 45 seconds, the reported timecode will overflow past the 24-hour maximum you can store in SMPTE timecode, and therefore will go past 0 hours, 0 minutes, and 0 seconds again. That means it's extremely difficult for an enterprising user or another DAW to reverse this issue, because you can't just divide by 4.35. In the instance of errors like this, a user who believed they would be able to utilize an AES31 import or export may be deep into their project before they discover it isn't possible, and will suddenly find themselves trapped, and certainly not a free-range user. So, how can WAD avoid similar issues? By testing. Realistically, this issue could have been caught with relatively straightforward testing, but it does highlight the need to test with more than a single setup. If WAD only tests exports at 44.1 kHz, or with 24-bit audio, or projects that only use the first 10 minutes of a timeline, then we might not catch issues like this. Robust testing is important. My last woe isn't DAW specific, but is instead about poorly documented or difficult to access interchange formats. The documentation for the original Final Cut Pro XML interchange format for nonlinear video editors has rubbish documentation. Conversely, the newer Final Cut Pro X XML interchange format has beautifully laid out clear documentation, which makes it much easier to implement. AES31 suffers in a different way, in that the documentation is only accessible if you are a member of the Audio Engineering Society, adding yet another barrier to those who want to implement it. If developers have to battle through difficult to parse, difficult to navigate, or difficult to get hold of documentation in order to implement an interchange format, one of two things is likely to happen. One, the implementation will be wrong, leading to bugs or errors like the ones we've just talked about, making it less likely to work smoothly. Or two, the developers will give up, meaning the interchange format is never implemented at all because the cost to implement it exceeds the budget. In a world where interchange formats are often given a lower priority, making the implementation of the interchange format straightforward feels important. So what can we do at WAD? Not a huge amount, other than considering the quality and availability of the documentation when deciding which DAW interchange format or formats to support. So, now we can heave ourselves out of the moan zone and return to the point. Why and how should you prioritize DAW interchange formats and free-range users? Simply put, including a DAW interchange format means more people can use your DAW, even if they can't use it for everything. It enables new DAWs to be in the hands of consumers sooner, showing the things that they excel at, even while there are some elements that lag behind. For well-established DAWs, it allows more users to use your software to help with elements of their workflow, and your existing users will still remain. I would suggest that a DAW interchange format should be a priority because it makes business sense. Never mind the fact that it provides a more flexible experience for consumers and opens the doors, if you'll pardon the pun, for people to make their own tools to interface with or modify projects made in your DAW. For a moderately small additional step in your process, you can enable a whole host of benefits. As for how, I think it comes down to two things. One, researching the kind of interchange format or formats you want to work with. If your DAW is all about MIDI, then perhaps CMX isn't a great fit. If you've got the choice between two formats and one has easier to parse documentation, then that one is more likely to be profitable for you to implement. And giving the implementation of a DAW interchange format enough priority in the development plan that thorough testing is possible. If it's something that your development team are being incentivized to get right rather than rush through, then the likelihood of your implementation working properly is, of course, much higher. So, my recommendation to you, whether you're working on a DAW or a completely different kind of project, consider how you can allow free-range users in your products. I think you might just find that it makes business sense. Thank you very much for listening. Despite not being there to present live, I am currently in the Discord channel, so if you've got any other questions or comments, please send them my way. And I hope everybody really enjoys the rest of ADCx Gather 2025.
Alrighty, well, thank you very much to Will. And as he said, he's not actually here, but he's in the Discord. So if you have any questions, please post them in the channel there, and he'll be live, able to get back to you there. So next we have Cornet, who is going to be talking to us about designing an audio live coding environment. Cornet, if you'd like to share your screen, and I'll hand over to you.
Sure, thank you. Sharing my screen now.
We can see it. Brilliant. Thank you.
Nice. Okay. So my name is Cornet. I'm an audio software developer from the Netherlands. And I want to talk about an audio live coding environment that I've been designing for the past year or so, or been developing. I'm going to present mostly from my editor because it's more interactive that way. So I'm going to start with a little demo, audio demo. So that's abrupt ending, but what you've been hearing is sound that is generated in real time by this code that you see on the screen, basically. So I want to talk a little bit about the inspiration for this system, the design goals that I had when building it. Go over some of its features. It's still in active development, but there's some stuff to show. Talk a little bit about the implementation details, and if I have time, address some future plans that I have. So the inspiration came from many things. I'm not the first person to get the idea to generate sound with code. There are many systems, some of which have been around for decades. For example, C-Sound, I think it's from the 80s. There is Super Collider, which is a pretty well-known system that's also been around for something like 30 years. There's Max and PD. I think if you're active in the audio world, then you've probably heard of these. These are actually visual languages. So this is a screenshot from PD or Pure Data. And you can see it's kind of like a visual programming language where you connect boxes together with wires, which turns out it's quite a good way to program audio systems. I mean, it kind of works like a modular synth, right? So you have different modules and you connect them together with cables, and sound flows through them. So that's basically, a nice way to work. For me, I did want something textual, and the reason for that is that Max and PD are, they're designed to also be able to be used by people who are not primarily programmers, so artists and musicians. So in that way, they're a bit more approachable than textual programming maybe, but I built this primarily for myself, and I already learned how to program, so I want to be able to leverage those skills. And I found there's relatively little transferable knowledge between textual languages and visual languages. It's like a whole new paradigm. Well, there are a couple more tidal cycles and Strudel, which is a JavaScript port of tidal cycles. Tidal cycles is, I guess, a bit more high level. So I have Strudel open here somewhere. You can see I can hit play. It works in the browser actually. But here you work more on the level of individual sounds rather than like audio signals. So those are inspirations for the system basically. Most of them are far more developed because they've been worked on for decades basically. But I thought it would be a fun thing to try to implement something like this myself. It's written in Rust. I think most people probably heard of Rust, so I don't really need to go into that. And it's also built on two other technologies. One of them is Codo, which is a programming language by Ian Hobson, who is actually presenting at ADC next month as well, I think. And he's a Rust programmer, and he designed this programming language as an extension language for Rust. So the way I think about it, it's kind of like a Lua for Rust. So Lua is a language that is easily embeddable inside C and C++ applications. So if you want to make your application scriptable, where you can kind of script things at runtime without having to change your C or C++ code, then Lua is a really good choice for that. And kind of in the same way, Koto is a similar thing, but for Rust applications. And it's also, it has really minimal syntax. So it's like super quick and easy to write, and super easy to get things out of your head, like into the code. So I thought that was a really nice fit for what I was trying to do. So basically I built like a audio engine in Rust and made it scriptable with Koto. And for the actual DSP, so like the oscillators and filters, I lean quite heavily on a library called FunDSP, which is a Rust library for audio processing and synthesis. So it has things like oscillators and filters, stuff like that. So I didn't have to write all of that from scratch, basically. Then something about the design goals. So I had a few goals in mind when designing Ohm. The idea was to be able to express musical ideas elegantly and concisely. So if you try to develop like audio algorithms or you experiment with musical ideas in C or C++, there's quite a lot of boilerplate that you have to write. And every time you make a change, you have to kind of recompile your code. So it's a bit more low level. So it would be nice to have something where you can just experiment with audio and while staying in the flow, basically. So without having to think too much about like syntax details. I wanted a terse and minimal syntax. So basically that's what Koto gives me. I wanted it to be interpreted in real time, which means there's no compile step, right? So one way to show that, let me comment this code out. So if I have like a piece of code, so here it's basically a saw wave going into a low pass filter. And if I run this code, oh wait, I forgot to save. And so I want to change the frequency of the oscillator. I can just change it and hear the results immediately. By the same way I can change like the cutoff frequency of the filter. So the idea is that you make a change and you can hear the result immediately, and you don't have to wait for anything to compile. I wanted it to be dynamically typed, which means there's no types to worry about. So in a way that's easy, because it turns out everything in the system is basically the same type, which is a signal. So just a stream of numbers. So even if I just type a 0 and I have a little print function, so I print it to the console, you can see it's like a continuous stream of zeros being generated and sent to the audio output, right? So that way everything is kind of like a stream of numbers, and you just pass these streams of numbers into different nodes. I wanted it to have an open design, so that basically means that I didn't, for example, want to have a synth that let me turn off Copilot, that have to like, I give it a pitch and a cutoff frequency for the filter or something like that, and have an entire synth in one function. I kind of want to take these things apart and just have like a separate envelope and a separate filter that I can route in different ways and kind of build the synth on the fly, right? So kind of an open design that way. And I wanted to have sensible defaults. So for example, if I just generate a saw wave and I don't specify a frequency, it chooses one for me. And if I just pass it to like a low pass filter, And I don't specify frequency, it just picks like a sensible frequency, right? So that way you can, I don't know, you can just try things out really fast without having to fuss over all the details. So then, yeah, I wanted to go over some features that are in the language. So there are a lot of like built-in audio nodes. So there are oscillators. I don't know, like a triangle wave or a saw wave or a sine wave. Those are all built in. There are filters. So there's a low-pass filter, and basically the low-pass filter is defined here. Make it a bit more readable. So the low-pass filter is just like a convenience function that takes an input signal, a cutoff frequency, which is optional, and a resonance value. And inside the function body, I take the input and I send it into a state variable filter, which is like an audio node that's built into Rust, that is set into a low-pass node, and that get the frequency and the resonance as parameters. So there are also some different types of filters, like a Moog filter, one-pole filter for smoothing signals. So there's various stuff built in. There are envelopes. So I can take, again, a saw wave and multiply the output by an envelope, and this is an AR envelope, so attack release, super simple envelope, and I triggered this like every well, at 1.5 hertz, right? It gets triggered, and then yeah, we kind of shape the volume of the signal over time. So yeah, you can use envelopes like that. Of course, you can also use them on filters and stuff like that, so you can kind of recombine them. There's built-in effects. So here we have, for example, flanger and a delay. So you can kind of hear the effect. Sorry, I said delay, I meant reverb, of course. There's built-in sequencers. So here I have a sequencer that is sequencing an array of values. So these nodes, so C3, E3, they get kind of played in sequence by this trigger. And then I have a little utility function, which means pitch to frequency. So it converts this to frequency, and I pass that frequency again to a saw wave oscillator. So I do this. So then I can, sequence different values. And again, you can use this also to sequence other things like cutoff frequencies, or you name it. You can, of course, combine these things. There's audio file playback. So I can load a file from disk. I have a little folder here with samples, and those are just like small WAV files. And when I type the name of one of these, it gets loaded. So now it's just looping this file. I can play it back at different speeds. So basically the way it works is I have this file function. I load it with the name of the sample I want to load. I put that into a variable, and then I can call the play function with this variable, and then we'll play it back. I can do the same thing with file, or with let's say sample buffers, right? So I can define a buffer which has the length of the sample rate, which is 1 second in the current sample rate. And then I can kind of write a saw wave into that buffer, which is happening here, and then read it out, and maybe read it out at a different speed. And turns out you can do all kinds of things with this. So for example, here I've defined like an echo or a delay effect in terms of using a buffer, right? So I have a buffer, and I read from it, and then I filter the sample that is in the feedback loop and then write it back into the buffer. So this way you can, kind of define a delay effect entirely in Koto. I also have a one-pole filter somewhere. So this is like a filter implemented with a buffer. So then we just need one sample to store the previous sample, but we can actually use this to implement a filter. It's not very efficient to do it this way, obviously, but I thought it was interesting that it was possible. So yeah, those are the sample buffers. Of course, there's ways to do abstraction. So, which is functions. There's no classes or anything, but there are functions. So I can define a function here. I have a function that is a hi-hat. So I pass some noise through an envelope and then through a bandpass filter. And then I get kind of a hi-hat sound, right? Well, there are like arithmetic operators. So you see them already. Here's the multiply operator, for example. And that gets kind of overloaded by these audio nodes, right? So if normally in Koto, in the language, you have, of course, a multiply operator. But if you multiply two audio nodes, they multiply their signals. So you can use that to do kind of DSP operations. Or there's all kinds of utility functions, for example, to convert frequency to pitch. I mentioned already. There's some useful constants. So there's stuff like pitches or scales that you can. So a scale major is an array of pitches that you can use to do stuff. And one really nice feature, or that I found really nice in Koto, is the pipe operator. So normally in like a normal, I don't know, like any C-like programming language, the way you would pass functions to each other would be in this way, right? So I have a saw wave oscillator. I pass its 100 Hertz as its argument, and then I pass the output of the saw as an argument to a low-pass filter. And I mean, that works. This is also valid syntax. But it's kind of difficult to read, right? You have to read it from inside out. So what you can do in Koto is, I think some other languages like Elixir also have this, but you can pipe the output of one function into the next function. So basically what this does is it takes the output of this function and applies it as the first argument to the next function. So here we apply the output of the add function to the square function, then to the multiply function. And that way you get kind of you can read it from left to right, like a signal flow. And the way I set it up here is that the first argument of a function is always the input, right? So it's an input signal. So this way I can kind of arrange nodes with these pipe operators and read them from left to right. So that's really, convenient. I think I'm running a bit short on time, so I'm going to skip some stuff. So one thing that was really important to me is hot reloading, right? So I showed already, I can make a change and I hear the result immediately. So here I have a sine oscillator and I modulate the pitch with an LFO. And one thing that I don't want is, for example, when you change the frequency of the LFO, that it kind of jumps, right? You want a smooth. So if I change the value, you never hear like a discontinuity in the sound. It always kind of it continues where it was. And the way that works under the hood is basically, so when I re-evaluate the code, I create a new audio graph. So the code gets turned into an audio graph. So for example, here we have a fixed value that's going to an LFO, and the LFO is going into a multiply operator that's multiplied by another fixed value. And some of these nodes, they have state, right? Like the LFO has phase as its internal state. So when we reevaluate the graph, we kind of copy the state from the old nodes to the new ones, wherever possible, right? So that, yeah, in that way we get basically no interruptions, no discontinuities in the sound. So that was that was quite important to me. Yeah, seems like I'm pretty much out of time, so I think I'm going to skip the rest. I just want to mention the code is open source. It's on GitHub. So I think the link to my GitHub is also on the speaker page. If you want to check it out, you can find it there. So yeah, this was my talk. Thank you for listening.
Thank you so much, Corné. Look at all those applause there coming in. Really great talk. Thank you very, very much. You can also post your link in the Discord as well if people can get you access to it there. And of course, you can also join for Q&A after the next session is done in Gather. So if you'd like, will you be around for Q&A and Gather in 20 minutes?
I have to run right after this.
Okay.
But
no problem at all.
Discord. If someone has questions, you can post them in Discord, and
brilliant.
I can answer.
That would be fantastic. Yeah. So if you have questions, please post them in the Discord channel, and they'll be responded to in due course. So I'm just going to say thank you very much, Corné, and I'm going to send you back to the backstage. And so next, I'm going to call up Martin Swanholm, and Martin is going to be talking to us about the helicopter view of audio ML. So Martin, if you'd just like to say hi. So Martin's is a pre-record, so we're just going to, he's just here to say hi now.
Hi everyone. Nice to see so many here. And yeah, this talk is just if you're starting out, and it moves really fast, so there's not a lot of detail, but it's kind of a way to just know where to begin to look for approaches to your problem, hopefully. And I will also post some bonus material that didn't make it into this video, but there are a lot of audio examples that will be, I will post a link in the Discord chat. So go check that out afterwards whenever you get a break.
Brilliant. Thank you, Martin. So we're going to cue the video. Thank you.
The purpose of this talk is to give a very high-level overview of audio machine learning in the form of neural networks, specifically model architectures. Those are the main building blocks in the sense that they are the actual wirings doing all of the computation. I hope that this can serve as a starting point for exploring different approaches and methods, especially if you're new to machine learning or if you have an idea for a specific project and want an overview of what generally works in different contexts. Now, of course, from a helicopter perspective, it's not always possible to see all the details, but hopefully we will see the big picture. Let's begin by examining what machine learning models are designed to do, the tasks or applications or problems that they are built to solve. These include various forms of transformations, generation, classification, segmentation, transcription, just to name a few. And as we can see here, the task can be framed as mappings across modalities. A modality is the kind of data a system operates on and is defined by its source or information channel. Examples are audio, images, and video, but it can also be more symbolic representations like text. In audio, we have symbolic representations like musical scores, MIDI notes, or even control parameters such as for synthesis. A representation is the concrete form of a modality as it's presented for the model. In audio, we have raw waveforms, spectrograms, or discrete tokens. In short, modalities will always be given by the task, but representations can be chosen according to other requirements. And not all representations are suitable for a given architecture or training setup. The premise of machine learning is to take data and feed it into a computational model, in this case a neural network, which transforms it into new data in the form of predictions, classifications, signals, or other output. The model is trained by adjusting internal parameters via a clever class of algorithms known as backpropagation. This is to minimize a loss function across many training examples. The system learns patterns and structures, allowing it to generalize beyond the explicit examples. So what is a neural network? Well, if we zoom in to the lowest level, a neural network consists of nodes or cells called neurons in a directed graph. Each neuron forms a linear combination of all its inputs, and then it applies an activation function, and then it outputs the result to the next neurons. An activation function is a nonlinear mapping, and it's crucial to model complex behaviors. Some activation functions pass only positive values, and others squash the input into a fixed range. Now, if we zoom out again a little bit, we can see that those neurons are usually arranged in layers. We have an input layer at one end and an output layer at the other. And as data moves through these layers, they can represent more and more abstract or higher level features. This kind of fully connected networks, or multi-layer perceptrons, as they are sometimes called, are essential building blocks in almost all model architectures. But they are seldom used all by themselves. While they can identify and interpret patterns, this performance comes at a large computational cost, and it doesn't always scale well to the kinds of tasks that we care about. There are much more efficient ways where we can exploit the fact that audio contains local patterns that repeat at different scales. Patterns or features can be captured much more efficiently without connecting every neuron in one layer to every neuron in the next. And this is what happens in a convolutional neural network, where we make use of convolutions. These are similar to digital finite impulse response filters. They have a relatively short set of coefficients that are applied repeatedly, sliding across the input or each layer. As with any of the architectures, the input is not always a single channel. It can be multi-channel, stereo, microphone arrays, multiple stems in music. As long as the channels are meaningfully correlated in one way or another, it can provide extra insight and improve performance on tasks. No matter the input channels, in a convolutional network, each layer usually applies multiple filters. And this means that the representation grows in one more dimension than the input signal. These extra channels that are emerging are called feature channels. And that is because each filter becomes a detector for a feature. As we progress through the network, the sequence length usually becomes shorter by the use of pooling, stride, or other downsampling. So feature channels increase, but other dimensions shrink. Depending on the whole setup and what we want to achieve, if we compress the dimensions a lot, we get a bottleneck. And this can compress the information because the network has learned common patterns in the training data. Bottlenecks can be useful for many purposes: dimensionality reduction, forcing feature abstraction, and reducing computation. For example, we can produce embeddings, compressed representations that are also used for many purposes. Or we can make what is known as an autoencoder. It has an encoder part which compresses the signal into a very compact and lower dimensional representation in the so-called latent space. Then a decoder reconstructs the signal back. Variational autoencoders extend this by adding some amount of randomness. This enables generative use and variation, like interpolation between sounds. A U-net is an architecture which is kind of shaped like a U, and this basically an autoencoder, but with skip connections between corresponding encoder-decoder layers. Skip paths let the decoder reuse fine-grained detail, which could otherwise be lost in the compressed bottleneck. And this makes it far better than a plain autoencoder for tasks needing both global context and local precision, like denoising or source separation. Jumping back to CNNs a little bit, they can have a range of dimensions. For audio, we usually use 1D or 2D depending on the representation. So for PCM waveforms, they're usually 1D, and 2D for spectrograms or other time frequency representations. But CNNs come with issues. Filters are short, so much downsampling is needed before neurons can hear what is going on in larger timescales. This scale is known as the receptive field. Downsampling also means that fine detail can be lost. And for streaming, the input must be chunked, which further limits context. Recurrent neural networks fix some of these problems. They process sequences step by step and carry hidden state forward for each time step. These are updated with new input, and it gives the model an implicit memory. The hidden state can then influence later output. RNNs can in principle handle infinitely long sequences. The most efficient RNNs in use today are long short-term memory and gated recurrent unit. They mitigate some of the training issues that plain RNNs can have by clever gating mechanisms that control the flow of information. They regulate what information is either stored or discarded or exposed at each step. They can be bidirectional, so they can look forward as well as back in time, depending on the training setup. Even with these gating mechanisms, though, at each time step, very long-term relationships can get lost. And also, because of their sequential nature, the training is more difficult to parallelize, which in practice means slower training. Another way of handling these problems were addressed by transformers, introduced in 2017 for translation between languages. It was later used for text generation, image processing, and audio. The main innovation is the concept of attention. And this is a way for the model to decide what parts of the sequence should influence each other. In effect, it creates a map of relationships across the entire sequence. And this allows points far apart to exchange meaning. Multiple heads do this in parallel. Each head learns to focus on different aspects of relationships. So this can be local continuity or long-range structure, or some other subtle correlations. And then this whole attention thing repeats through stacked layers, just as in the other architectures. There are two flavors of attention. For single sequences, self-attention is used, and this is what's used in most language models. When we cross modality boundaries, we often use cross-attention, where the attention calculation is performed between two different sequences, often in an encoder-decoder setup. The input representation for transformers is often MEL spectrograms. Other representations are tokens produced by some vector quantization process or a neural codec like encodec. To see an example of transformers in audio, we can look at the whisper transcription system, which was introduced a few years ago. It uses this kind of encoder-decoder configuration. The encoder processes audio into complex features, and the decoder generates text tokens step by step. The cross-attention connects the text token generation back to the encoded audio features. And the decoder also uses self-attention at the same time. The multi-head attention can capture both short and long-range relationships like phonetics, prosody, rhythm, semantics, or other kinds of overall structure, all in parallel. One problem with transformers, though, is that the computation scales quadratically with input length, or the context it can operate on. A somewhat different approach, introduced surprisingly recently, is differential digital signal processing. This builds neural nets around classic DSP blocks like oscillators and filters and reverbs, which are implemented as differentiable modules. So instead of generating audio sample by sample, the model predicts control parameters for these blocks, while the DSP handles the actual waveform. Traditional audio ML has to brute force its way through spectrograms or raw samples, wasting capacity, only then to rediscover already known structures. DDSP shortcuts this. It leverages existing audio knowledge. This is more efficient and interpretable and produces high-quality sound with less training data and less compute. This has been used for many different tasks in music, speech, and sound synthesis. Because, as we have seen, all of these model architectures have different shortcomings, hybrid architectures are common. For example, combining CNNs, which are good for local feature extraction, with RNNs or transformers that are better at capturing long-range dependencies. A generative adversarial network trains two networks at once, connected together. A generator that produces candidates and a discriminator that judges them against real data. And this adversarial setup forces the generator to improve until its outputs are indistinguishable or very close to real examples. GANs have been used very successfully for speech synthesis, music generation, and upsampling tasks. Diffusion is a method combining a specific training setup with an architecture, often a UNet, since, as mentioned, it's good at denoising. The model is trained by adding noise to a clean signal and learning to reverse that process step by step, so that even pure noise can be turned into a plausible signal. And this interesting figure shows the noise distribution on the left, and it also shows the distribution of the real training data on the right side. And it shows the sequence of steps in between, gradually turning noise into something that resembles real data. In a generative task, it can produce very diverse and high fidelity samples. And in denoising, it's also very powerful. But it is computationally expensive, both in training and in inference. So it's far from real-time ready. Summing up, we can see that practical trade-offs will always exist between fidelity, latency, accuracy, compute, long-term context, and training data requirements. And in all cases, it always depends on the task. Now, let's see what we can achieve by using some of these architectures and techniques. I wish you all happy experimentation and development.
Alrighty, well, thank you very much to Martin there. Fantastic talk. Martin, I think you can head over to Gather, so if there's any questions, go and find Martin in the auditorium room. So I don't think any of the other speakers are going to be there for Q&A, so rather than do a proper Q&A session, I think you can just find Martin in the virtual venue and group up and have a chat. Otherwise, we're now going to have another break of the talks, so if you're joining us in the virtual venue, please head over to the poster session, which is about to start in the poster building in the virtual venue, where we've got another array of posters for you to view. So if you joined the earlier one and there were ones you missed, please head over and check out the others. Otherwise, we'll be back again at 1810 UTC. 18:30 UTC, my apologies. So we'll be back at 18:30 for the next 4 talks before our closing address. And then after that, we have our quiz back in the virtual venue again. Okay, thank you all, and look forward to seeing you back here at 18:30. Thank you. Alrighty, welcome back, welcome back. We're just going to give a moment for people to rejoin as we go into our last block of sessions for ADCx Gather 2025. It's been a fantastic day. Thank you all for being here and to all our speakers that we've had so far and still to come. Just a reminder that we're going to have another 4 sessions now, so a slightly extended block compared to the previous 3-session speaker blocks. Then we've got our closing address immediately afterwards that will be here in Zoom, and then we'll be heading over to ADCX to the ADCX Gather quiz, which will be happening in the virtual venue from 8:10 UTC. So we'll head over there, and that's hosted by the wonderful Andrew Sheps, who will be there, our quiz master for the session, and he'll be there with a bunch of questions for you to answer in Teams. So please head over there after the block of sessions. So now I am delighted to bring in Hakwin. It's coming now. One moment. Are you here? Yes, you are. There you are,
Hey,
sir.
everyone.
So if you'd like to share your screen, and I will hand over to you to give us your talk on From Idea to Online Sale, the full journey of building an audio plugin. So over to you. I think we see your screen share coming in any moment.
Can you see it?
Yes, there it is. It's there. Perfect. Over to you. Thank you very much.
Thank you. Wow. Thank you very much for the opportunity to the audio developer conferences. I am a really big fan of the ADC videos in YouTube. I've spent a lot of hours watching and learning, so great to be able to give something in return. I decided to present this From Idea to Online Sale talk because I wished when I started I had some of the details that I will show you. That is not only to build a plugin, it's not only to develop the audio processor, the audio plugin editor, and just the development part. There are a tons of other details that you will have to work. So yeah, that's my idea, just to give a really quick summary of things to take into account when developing audio plugins. So to tell you a little bit about me, I'm Joaquin Saavedra. I'm from Uruguay, and I study music production, sound design. In parallel, I did electrical engineering and computer science. Never finished those. But yeah, I have more than 5 years of experience in the audio plugin industry, and I've worked in more than 20 projects all over the, I don't know, the spectrum of experiences, good experiences and really bad experience. But those are the ones from where I learned more. And yeah, usually clients have great ideas, and I love to help them bring them into reality. And there's always a lot. I'm kind of in the business part a lot. So yeah, this year I've co-founded and I'm the CEO also at Edge Audio Labs. So in Edge Audio Labs, we provide software development services for other companies who want to make real their ideas. And it's specific for audio and music industry. So in that sense, I feel like I can add value to this topic, or I have some experience, because my job is basically looking for clients that want to develop audio plugins or other types of audio software, and then make them, they come just with the idea, and we have to make it reality. And that is kind of the overview of what I'm going to talk today about. So yeah, to give you a little overview, and the idea is to see here the full picture of the what I'm going to talk about. So we always start from an idea, then the idea is to create a plan, develop the software. That's usually, this is the point where us, and I say us because it's the audio developer conference, where we think and spend most of the time, and we think a lot of this specific step, but we tend not to think a lot about the other steps that are involved. So yeah, there's testing, copy protection, installers, online sell, customer support, and really a huge amount of other stuff to consider. And I think kind of planning all this is the key thing that I wanted to tell you. Like, we have to plan every step of one of each of the steps of these ones. And what we really want to avoid, and this is why I think it's important, is like this. That is, a lot of the times is what really happens is that we plan, we make the installers, we develop something, we make a second version, we copy protect it, we test, we make the Windows version, and so on. So that's I think it's not comfortable for anyone, and it's important to see the full picture to try to avoid this. And one concept in this sense, one concept I really I want to make this point is like, all the time try to think one step further and think what is going to happen next. What is the next plugin that I'm going to launch? What is that the user is going to want next month, or when I launch version 2 or whatever. Always try to think that one step further to avoid problems and miscommunications. So yeah, starting from point 1, you always need one idea. And I say one because we can do all the ideas at the same time. Usually we try, or people who are doing plugins try to do all the ideas, or try to make everything in one product. It's useful to start by one idea and making it one product. And we have to analyze which is the unique value that is adding, and if there is a gap in the market that we can fill. Maybe there are tons of the same plugins that you're doing, and it's probably not going to work that well, rather than if it's very unique and there are not other solutions similar to it. So yeah, think about the target user, look for references. This is very important. And then start to get early feedback. Talk with your friends, with colleagues, to try to understand if it's just that you love your own idea, that happens a lot, or if other people also like your idea. And then I think that writing it down, documenting, and refining it is very important. Just to know, which are, I don't know, your target users. Are you going to target musicians, producers, audio pros, I don't know, sound designers? It's very different. So writing it down, it's very useful for one to get more clear on the idea. Yeah, and another really big point I want to make in this presentation is learn to say no. This is really a common issue. Like, we can't have every feature in our plugin. We just can't. It's impossible. And when we get like too perfectionists, it's that the project becomes endless. You start fixing up. So yeah, I think we have to learn to say no. And when we reach, I don't know, the 98% of what we want, just launch it and trust your idea and just launch it. So the second point, I think that is the most important point on all the things, that the steps that we have to do is to create a plan. So it's the most important part, and yeah, it has to do with the technical description, but also has to do with a lot of marketing and business side. Here in the technical description, I wrote like supported platforms. Are we going to launch for the formats for which of the operative systems? Obviously, what actually does and how it does it. Every feature has to be in the technical description. The technologies we're going to use. Are we going to use Juice or just Juice, or any extra thing needed? Maybe we need PyTorch. Maybe we need some time stretching libraries. It's very important to plan the timeline. If we have any deadlines, are we going to, I don't know, target to sell on Black Friday or in Christmas? I don't know. It's important to have it plan, and each week what is going to happen, how are we going to advance. So we are very clear, and yeah, the same with obviously with the financial plan, that sometimes developers are not doing the financial plan, but we have to be aware of what is going to happen and what costs are involved in each of the stages. Then it comes the fun part, at least for me, the software development. And yeah, I separated this into the user interface, user experience part and the DSP part. So in the user interface and user experience part, we have to sketch, start by paper, and then design it, actually do a design in Figma or any equivalent application. And it's important for me, and a real point that, yeah, really happened to me a lot, is like we need to plan all the interactions, not only the buttons and sliders, but also the hovers, pop-ups, meters, shortcuts, like the keyboard shortcuts. What happens if the user has the plugin open and you start to press? Do we want something to happen? That has to be planned from the scratch and has to be, yeah, agreed in all the team, animations and all other kind of interactions, and then implement the design into code. Then in the DSP or processing, because maybe you don't have actually a lot of digital signal processing, but you might have other type of audio processing. Yeah, I recommend to start in a prototype or an MVP. That Python is very useful for that, like just to check that I know how to do this processing and it works correctly. I also recommend to look for solutions, like if you're doing I don't know, distortion, maybe there are some already open source plugins or other projects that where you can get real good analog distortions, and you don't have to implement everything from scratch. Then obviously implementing in C++, that probably is the thing that takes most of the time. And it's very important to have critical listening, people who knows what they're hearing and yeah, listen not a lot. And then it comes the optimization, where we have to test and be sure that works on all the with all the real time constraints that we have. Yeah, so this is the fun part. And then from here, this is at this point, the product is not at all finished. There are a lot of steps that has to be done from here. So I'll continue with those, but it's important to make that point. This just when we have the plugin developed, there's a lot of things to go until we actually make the business work. So then about testing, obviously we have to test while we develop. So we will have some internal functional testing to check that things are working when we develop. But then, well, as I already said, we have to do critical listening testing, alpha testing. That means in an internal team have build that everyone's tests and documents and solves the problems. And then I really make this point important, the beta testing, like have a group of people external to the development team that will test and report all the problems. This is very important. They will test in a variety of circumstances that you might not think about. So here's when problems start to arise if something is not correctly developed. Then the compatibility testing, like testing in different DAWs and in different operative systems. Obviously, versions is something really important to take into consideration. Another point I have to make is like in the audio side, sometimes testing in a lot of buffer sizes, sample rates, test the latency. It's also very important and could be problematic. Then it comes the copy protection. So we can use external solutions like iLog or other solutions that are already made, but we have to integrate. So this is something to consider. Building a plugin also requires to copy protect it. You can build your own solution. We have done that at Audio Labs and it works, but takes a lot of time, obviously, and it's something that you will do if you can, and then you will reuse it. If not, you're not going to make it. So in that case, you will need to develop an API in connection with your plugin. Maybe you can make an installer hub where the user will have all your plugins. You will need to think what happens if the plugin gets cracked. So you don't want that to happen. So maybe you will use activation codes and then, or maybe you use username and passwords. There are different ways of implementing this. So you have to think about this. For example, other things to consider is how many activations per cell are you going to offer to each of the users? Can they activate in infinite amount of computers or just 2 computers, for example? How are you going to manage that? That is very important to think before launching, obviously. The same with the trial. How long is the trial? How does the trial works? Then the installers, things to consider. Have a convention on the naming of the versions, for example, that one. But you have to be consistent so the users know what to expect and where to look when they're going to download, have all the versions available. I recommend these applications to create in Mac and Windows. Use the Inno setup. I think are the most common. Code signing here is very important. This is something you might need to start thinking from the beginning. It's something that I usually recommend to my clients to start thinking about getting the Apple Developer Program and the Microsoft Azure Trusted Signing in place once we start to develop, because there's some stuff that takes time because you have kind of bureaucracies. And yeah, you have to have some documentation sometimes to have those, but it's really important to consider. And obviously they have some costs. Then, well, considering the installers has to install all the dependencies, maybe libraries or others, and you need to be worried about the compatibility of the installers. Then it comes the online sell. So you obviously need to plan to do a marketing plan, social networks, have your pricing. Are you going to do like I don't know, bundles, for example? How are you going to launch it? Are you going to sell one-time purchase, subscriptions, freemium? That's I have a type of there. Like, are you going to offer freemium model? That's something to think about. And then obviously the sell channels is important. Obviously the main way of selling is building your own web. Maybe you have it, maybe you need to build it. So if you're planning to build a plugin, start thinking about, or I need to have a web that I can sell, maybe integrate through Shopify, Stripe, PayPal, or whatever you are going to receive the payments. Put a place where the users can download the installers, all and about the payments I was saying. All those details are things that you have to consider. So yeah, and then the customer support. So you will have to have a frequently asked questions on your website. Think about which problems can the user have, will the user have. So try to fix those and in the web, and yeah, communicate with your users through different channels. The forums presence is very important in my experience, so I really recommend, like, I don't know, Gearspace or Sand on Sand forum on Reddit, even Reddit, but try to answer your users in the social network also, and prioritize fixes when you have to. And then here I did a list of other stuff to consider that I think there is a lot of things here. Documenting, paid patents are things I never thought that I was going to write a patent, but I had to in some projects, because when you have intellectual property to protect, you have to be dealing with those kind of things, or licensing, maybe artists, or well, financial and legal things. Legacy support is a problem that something we have to consider, and long-term support and infinite things. So here, like my conclusion that I want to give you is try to think all over this. I try to just bring up questions and yeah, show you the entire thing, the entire path of from the idea to what it actually takes to build a business and a plugin around an audio plugin. But my conclusion is you have to create a plan considering all of these things, and yeah, basically plan as much as you can, even if you know that you will probably end up changing some of the things you planned. It's important to plan and always plan with a time frame and plan financial plan. So plan the money that we are going to spend in everything, and plan and write your plan and share with the team and with the clients and with all the people and with your co-founders the plan. This is really important. So yeah, I think that was all. I will be for the question and answer in Gather and the Discord channel. I will share the slides, and there you have my email and my LinkedIn if you want to feel free to contact if you have any questions or whatever. And yeah, you can also visit our site at edgeaudiolabs.com. We do fun stuff, and if you ever need any extra hands on a project, you can reach out to us, and we will, yeah, hopefully help you, or we can collaborate. So, yep, I think that was it. Really, thank you for the opportunity to the Audio Developer Conference. Yep.
Thank you. We really appreciate you being here. It was fantastic. Thank you so much for the talk. Really appreciate
Thanks,
it.
Jim.
And yeah, so as mentioned, head over to Gather after this block of talks if you want to catch up and ask any questions. That will be happening after the closing address, and we do have the quiz happening at that time as well. So you may have to make a choice between hanging out and asking questions or going over to the quiz, but I'll leave that up to you. But thank you very much. I'm going to send you back to the backstage now, and I'm going to bring up our next presenter. So our next presenter is Andy Normington. So Andy is a frequent name at the ADC conference. I've seen him many times before, and he's just coming through now. Andy, are you there? There you are.
Hi. There I am.
Okay. So would you like to say anything to the audience about your talk, which is working with the garage door up, letting others take a look before you're ready?
Yeah, just to say a bit of my background. I work on embedded software and tooling for engineers to get our jobs done and working smoothly together. So I'm working with lots of teams building Focusrite innovation products. Yeah, thanks for having me here at ADC. I'm excited to be here. This talk isn't super audio specific, but it is developer and it is very much conference. My talk's going to be pre-recorded, but I'm here in real life just now saying hello, and I'll be in the Discord chat during the talk and after. So listen and chat with me while you're listening if you want, but I'll be around to do Q&A afterwards too. Cheers.
Brilliant. Thank you. So we're going to roll the video now. And so over to you, other Andy.
Hi, I'm here to talk a little about working with the Garage Door app, what that means, why it's something you should think about, and some things you might like to try. Have you ever worked in a really close team and everyone knows what everyone's doing and you're all in sync and you're each doing your bit and you know how to support each other and you just keep on ticking off ticket after ticket, and every time you do, we'll look at each other and we shout synergy and perfect unison? I mean, it's magic when stuff like that happens, but it's super rare and it takes ages to get to that point. Have you ever spent a week trying to debug a problem that's really opaque and you're picking it apart but nothing's making sense and you're banging your head on a brick wall, and eventually you go and ask some senior magician and they say, oh yeah, that happens, it's a known issue, you just need to uninstall that driver and use this version from a branch instead, and you just want to scream, oh of course, why did nobody tell me that? Or maybe you've been the senior magician and you just want to scream, why did you wait until now to ask me about it? Well, we can't all work like the first team. Sometimes you need to work on quite different things to each other. Sometimes you need a specialism, and there just isn't a whole team to work with. But it sucks being in the second situation. I want to present a way of thinking about your work that helps get some of that team's happiness before your team is the dream team with everything figured out, or when you're not in a big team at all. I've best seen it described as working with the garage door app. Robin Sloan talks about it in reference to the experience of being around physical craft businesses. He talks about the experience of walking past a glass blowing studio near home with a nice sign outside and the windows open, and a woodworking shop with the door propped open every day. And what a delight it is to ride past the door every day and peek in and see all the tools and the boards stacked up and what's different to yesterday and what commission's going on at the moment. Working with the garage door app is thinking about this as how you do day-to-day personal actions, not just product demos and customer feedback like we try and do for our products. Where we often talk about release early and release often, I'm talking about making it easy for people to see what your work looks like when it's not releasable. This applies for the way you work through big multi-stage things and big projects, sharing while it's in progress, but it also applies to small stuff that is finished, but it's maybe not significant enough to go and shout about. Your personal crib sheet for analyzing a pile of debug data, maybe. You're not going to formally release it and brand it version 1.0 and launch it, but you can totally just stick it somewhere that other people can stumble upon it rather than keeping it to yourself. And they can use it, they can contribute to it, you can learn from that too. Working with the garage door app means just giving some more visibility of how you're building what you're building when you don't really have something that you can present or publish or release yet. Allowing people to stumble upon stuff because you don't know what will be valuable to them until they come asking for it. So let them discover it in their peripheral vision instead. But why would anyone care what I'm doing right now? It's not worth shouting about. It stays in my notebook until I write it up and then I'll share it. Well, there's a lot of valuable stuff in your half-baked notes, and a lot of that stuff won't ever get written up. Some of it because it's temporary and you've since iterated on it, but some of it because you just haven't finished yet. When you open up the garage door and you make that stuff visible, you might share that I tried X, but Y and Z were tricky, so I didn't carry on. And someone else might read that and say, oh, cool, I tried X too, but I didn't even know about Y and Z. I really want to make Z happen. Can we do that together? You might reduce wasted effort. Someone else might be working on something already or have already solved this problem, and you can save yourself from a world of pain reinventing the wheel. Someone might see the way that you're approaching the thing and think, why would you do it like that and not like this? And you might learn about a new way of approaching something. By writing stuff down in a way that people can pick up on it asynchronously, you're also leaving a trail of breadcrumbs behind for the future. And you get some documentation of the way that your team's working and how problems got solved when you're looking back. And if you do it, then other people might also do it. And then you get to find out about opportunities to collaborate with other people on stuff that you thought was going to be boring and only affected you. And you get to observe what other people are doing and how they're doing it, and build up your own amalgamation of the best practices and processes from all the stuff that you've encountered and pick and mix that. This always happens a bit, but normally only with stuff that's directly relevant to you. So you make an effort to communicate about it. Maybe the IT team, though, have a really slick way of doing reviews that you'd never thought of, and they'd never thought it was special enough to actively go and tell you about. The more you work in the open a bit, everyone gets more shared context. So we don't have as many detailed specialists who have to be consulted on every single thing. And we can all be more cross-functional and at least get an idea of how something works before we go and consult with the expert. You might notice that all these things are the kind of issues that come up for discussion when we talk about remote work versus being in the office. You get some of this kind of passive visibility for free when you're all working in the same physical space. So it's really important to find ways to restore that when you're not all in the same office. I think describing this as a way to approach work sounds pretty obvious, but people often don't work in this way, and there's some good reasons for that. What if it's not ready? Maybe you're right. If it's something that really needs to make an impression and you only get one shot at that, then be more cautious. But if you're amongst friends and collaborators and it's just that you're a bit embarrassed about it, I recommend getting over that. The pros of sharing outweigh the cons. Your thing might also never be totally done to your total satisfaction. You might as well get some value from it. You might find after getting the courage to share it that you've already hit the 80-20 principle, and making it really done is diminishing returns. A mentor introduced me to the Court of Done manifesto a few years back. you've got to take it with a pinch of salt, but it challenged me to reconsider how I thought about my work being not done until it was polished and complete. What if you'll look stupid if you share it and everyone's going to think that you're useless? So just tell them that you're not done and you want to share it because you value their input. People love imparting wisdom. Claire Sudbury's got a great talk where she introduces this stupidity manifesto, saying, let's stop making each other feel stupid. It's about being confident in your own ignorance and about being excited and about exposing the stuff that you don't know as an opportunity to get to learn stuff or get to teach stuff. She also includes a lot of excellent cat pictures in her writing and her talks, so that's well worth checking out, even if you don't like the content. What if you might mislead your colleagues into thinking that you've really thought about this properly and they trust you on that when actually they should take it with a pinch of salt? And maybe that's a hazard, so handle the hazard. Communicate the maturity of the project that you're sharing as well as what it is and what it's for. If you're writing guidelines, then make it difficult for someone to unsuspectingly assume that you've thought long and hard about it and got approvals for it and stuff. By naming it as work in progress or draft or labeling it, maybe share it from a personal area so it doesn't pop up amongst the rest of your best practices. In a team area, maybe share it in a personal area so it's a bit obvious that they're looking in your personal notebook, but you still allow them to access it and make it searchable. So, a lovely lofty idea. Hopefully you get the value. But what should you actually do? Beyond the basic response of just try and work a bit more in public and share things a bit sooner, I'll put forward a few things now that are a bit more concrete than that. The first basic thing you can do without changing your day-to-day workflow is to think about what is that door that you can prop open leading into your metaphorical workshop. For a lot of us, that's going to mean going and have a look at the permissions for your docs and your wikis and your repositories and see if people outside of your core team can even access those to read them. Consider making all that stuff open and readable by default. Often tools default to private, but do you need to do stuff in a private workspace if it isn't secret? Part of my reason for giving this talk is that I want to share some things that I've picked up along the way, nosying in other people's open garage doors. I've got 3 specific things that you might want to try out as a developer trying to work a bit more in the open. First, I want to talk about a how might we doc. These are a bit like RFCs, but with a really low barrier to entry. So you haven't got a recommendation yet. You're not looking for approval because you're not going to go and make any big changes before you go and do a bit more thinking and research and testing and discussion. Crucially, you're probably not going to send it around and announce it to everyone, but you are going to write some notes and leave them lying around for people to stumble upon and for your search tool to find. When someone else pops up with the same problem later, or you come back to it, you're halfway to an RFC already. And maybe others have already spotted it in the meantime and commented and given it a bit of thought. So we want to get better at architecture diagrams, say, and sharing those diagrams in a useful way was a problem that we identified. I knew there were a couple of different ways to solve it. Wasn't really sure what to do at the time or when we were going to get around to it. I did a bit of research that I wanted to capture, so I wrote it as a how might we doc in this labeled space. Just with some options of where we've got to, trying to put my finger on what the problem is that we're trying to solve and what I've learned about each one so far. Lots of links and half-baked ideas of how we might implement these things and where the problems are going to be. I've since pointed a couple of relevant people towards it when it's come up in discussion, and a couple of people that I think might have a strong opinion that I could gain some more information from. And we've got a shared idea now of what the best option probably is, so we can start to experiment before we've met up and had a big pros and cons meeting and figured out the right answer and made a big decision. So that's a how might we doc, and it's just some notes putting a finger on the problem that you're trying to solve as context and what ideas you're exploring to solve it. The second thing I want to discuss is using a tool called Just as a way of doing documentation as code in a really lightweight way. So Just is a command runner. It can do a lot of clever stuff, but the big sell for me is that the syntax is easy enough for other people to read that you can use it instead of writing down your magic incantations in a markdown doc in your repo. So when you're noting down how to use the tools to build your project, don't just write stuff down as a tip in your README. Instead, write it as a recipe in a Just file and link to the Just file from the README. If the reader's using just, then fabulous. They can simply run the recipe in the just file and recreate what you did. If they're not, then they've still been linked to a readable text file. It still looks like a command they can copy paste to a terminal. It's still pretty figure outable without having to learn much stuff. Nobody's lost any functionality, but now you can actually use what you wrote when you do that action. So it gets updated when you find a better way of doing it, and you update your runnable script as your notes before you do it next time, or something in your process changes. So write incantations and processes down as a just file. That's your way of testing it as you go and sharing it with other people. And then it's already documented. When you commit the just file, you don't need to remember or bother to go and update the docs. All your docs need to say is, here's the high level how it works. Go look at the just file for the nuts and bolts, and we run it all the time as part of our CI workflow, so it's not going to be wrong. Finally, something a little bit fancier is a tech radar. A tech radar is a visualization that shows the way that you and your team or your organization is working. What patterns you use a lot, what tools you have in place, what platforms you're using frequently, or what you're just experimenting with. What I love about it is that as well as having all of your best practice stuff in the middle in this like a docked ring in the center of the radar, you also have all the stuff that you're trying to make changes to. So there's some things around the edge of the radar that we want to do less of because we've learned X, Y, Z now, or we've got a better option, or something else that we're just trying out. We can't recommend it yet, but it's a thing. If you're worried about sharing stuff that you haven't figured out yet and you're not sure you can get behind it, a tech radar is a great way of communicating that it's just an experiment. I'm not hitching my wagon to it yet, but if you've thought about solving a problem in a similar way, let's chat about it. This is something that we're starting to use in engineering at Focusrite. There's a really neat tool that I'm showing here that AOE developed for their own radar, and they've open sourced it. Really easy to get started with. We've got these different rings that reflect the maturity of the thing on the radar. The great thing about this visualization is that it can be changed and updated over time from text, but it still shows some history of how the usage evolved over time. So it's built in that you haven't got the whole thing figured out when it pops up onto the radar. There's a really low barrier to entry for just sticking something on the radar in this assess ring, low stakes. And then you can record the history of how that changed over time. There was a great talk at Lead Dev Conference last year that introduced me to AOE's tool, but also some ways of using this and some benefits of how it helps you to make transparent choices about how you're using different technologies. I'll link to those. My favorite, most satisfying moments are when I make a bit of an effort to work with the garage door up and it finally comes in useful and someone else latches on. I get my head into a problem that I think will be simple and it turns out complicated, and I get deeper and deeper down the rabbit hole until I realize I've spent way too long on it already and it's really not worth putting 40 hours into something automated that takes maybe an hour to do manually and only happens twice a year. But I've been writing my notes on Confluence, and then James pops up 6 months later and says, hey, I've got this problem. When you're looking at something like that a while ago, and I say, yes, I was. Start here, follow the breadcrumbs I left, and then I would love to make it happen. That is super rewarding. It would be great to make use of all that frustration that I went through. I've been consciously trying to work a bit more like this over the last year or so. So I don't claim to have a finished, thought-out philosophy of work here. I'm sharing a bit of my experience with the garage door open and some things that you might like to join me in trying out. There's a few things to be aware of, a couple of things to be aware of. The reason that it's easiest to write privately in your own notebook is because you know that you're only writing for yourself. I know presenting stuff can help to clarify your own thinking, and that's a good thing too. People say if you can teach it, then you understand it, and that's fine and that's lovely. But at least for me, I find trying too hard to put something in a presentable format can make it feel like too much effort to do. It's then a stage 2, and I just don't do it. There's a fine line to walk here to get the most out of it. Open the garage door up, maybe write useful titles or give a tiny bit more context than you might go to in your own private notebook, but still primarily write for yourself. You're still probably the main reader, so don't go to too much effort trying to make it presentable. Just leave the door open for people to have a peek. Don't modify your day-to-day working practices too much. That's all. I'm talking more about open by default rather than publishing often. Working with the Garage Door app isn't publishing, it's just putting some of your unpublished stuff in an accessible place. You'll know you're doing it when, if next time someone asks you about something, you can share, next time someone asks you about something that you can share some knowledge on, you don't get another to-do list item of write up what I found out about XYZ so that Sophie can carry on. You can immediately just say, yeah, I put some notes here when I was looking at that before. Have a look, see if it helps, and then totally let's have a chat about where the gaps are to fill and how we can work on it together to finally resolve it. Thanks for being interested. I've got loads of pointers to share to other resources that I've found and thoughts and references that have helped me out. They're here if you catch the slides later. But I'm also linking them in the Discord now for you to catch up on in real time. Let's chat.
Thank you to Andy for that wonderful talk. And as he mentioned earlier, he's in Discord if you have any questions. It'll also be in Gather as well. You can find him there. So thank you very much to Andy. Next up, we have Ryan Wardell, who is going to be speaking to us about Accelerate UI Development, Seamless Designer-Developer Collaboration with Web Tools. So Ryan, if you'd like to share your screen, and then I'll hand over to you to take us through this penultimate session. Thank you very much.
Thank you so much. Yeah. Hi, everybody. Thanks for joining. Really excited to be here at ADC to talk about plugin GUIs, but specifically how we can speed up UI development and overcome some pain points that I imagine we've all felt if we've worked through building plugins and apps. Quick little about me. For the past 20 years, I've worked in product design, product management, and QA, 13 at Avid, 7 at Universal Audio. I worked on dozens of plugins and DAW features over that time. Today I'm at Pace, where I run program management and manage the QA and support teams. And also on the side, I've got my own company Storyboard, where I'm working on plugins and audio apps. And a lot of that came from that need, along with a history of building products. So here's the challenge. Can we remove the error-prone step of translating UIs into code and instead give designers more direct control over what ships? And for years, I've seen designers hand off beautiful creations in their mockups and design tools, and developers have to spend weeks or months trying to rebuild them in our plugin. And that's just overhead. It slows us down, costs us extra money, and ultimately it waters down the vision as we have to cut scope and features to make a date. And so why does this happen, and why is this process so lossy? And when I say lossy, it's the same thing I mean in audio, like information is stripped out. The designing start as high fidelity, expressive creations in the design tools, but as we're forced to implement them through PNGs or SVGs and coordinate maps, or try to hand code layout rules, a lot can get lost. Gradients don't match, motion stripped out, responsiveness gets more hacked in, and designers lose trust of what they build is actually what the users are going to see. And that ultimately slows down creativity to try new things. And I'm sure many of you have experienced this, and it's important to say, I don't think it's due to lack of skill or effort on the developer or designer side. It's that the process itself tends to just be lossy. So can we create a designer-centric workflow to try to overcome this? And I think we can. And I'm going to walk you through how I've personally been able to overcome this. The solution comes from combining 3 things. We've got Juice 8 brings us a new web view, which are extremely helpful. And we hook that up through modern frameworks like React and Vite to give us a little bit more ease of development, and design tools like Rive or Spline. And you may not know Rive or Spline yet. That's okay. Think of them as more like next generation design tools. They're all web-based. They have collaboration built in, and they're built really around interactive design with 2D, 3D objects. They have state machines, do animation, and they even have physics engines because they get used in gaming. And all of it works in real time. And the evolution here is that instead of taking the designs and flattening them out, exporting them, or relying on third-party hacks or plugins to get them out of your design tool, we're going to load those files directly from the Spline or Rive into our web view. And it communicates over the JavaScript bridge, and we use the native support that each tool gives us for JavaScript React. And this ultimately lets the designers stay in control of the behavior, and while the developers can focus on solid parameter and other infrastructure. It's the same separation concerns we see with web development. Designers build out the front end, and engineers can focus on the back end. And it seems like plugins should be able to work that way too. This is a short session, and I'm going to give you some key details on what I think you need to know to where you can get started. If there's interest later, I can maybe make some videos, but for today, I'm really going to focus on how the pieces connect and why this workflow kind of becomes a really big shift, and how we build plugins and app UIs. Both tools are free. They do have paid plans, but it should be pretty easy for folks to get started and access these things. So to get started, first, Juice Web View gives us a really solid foundation. And there's a really great tutorial that you may or may not know about by Jan Wilczek. Said that right? And it's a great place to start. Definitely go clone the repo and go through the YouTube videos. This is what I did to get started. It really lays out how it all works together. And the fact that it has like a C++ and JavaScript side by side in the app, for me, it was really, really helpful in getting on board with that, but also debugging little idiosyncrasies about the web view. It doesn't use Reactivate, but that's fine. It really is there to teach you the core concepts. And there you can start handling any sort of special cases yourself, keyboard focus, shortcut keys you want to add, and keep an eye on, automation and gestures, things like that, as some DAWs can react a little differently. A good handle on how the gestures and parameters work is going to be really important as you start to integrate Rive or Spline into your workflow. And it's really important to note that both Rive and Spline provide JavaScript and React support, but there are many others. So if there's some other method that you personally want to look into, definitely check it out, as it's not just one way to go. So let's start. From there, we want to get into Rive, and I want to make sure you understand this. Rive is really where things get fun. It's a design tool, and it's really built around animation activity. You expose artboards, which have now been renamed to components, and other elements which you bind to juice parameters. And two key elements of this is the view model data binding feature they have and the state machine. So in React, you load up an artboard, you bind the juice parameters to your data model instances, and everything can behave in real time for what you design inside of the product. And I'm going to kind of go into here's a kind of a view of Rive, just so you get a sense of what it is. It looks more like what you would expect from a design product, layers, and state machine, all the time of different parameters. So definitely check it out there, but let's talk about how you actually get it integrated. And this is how we connect to Juice. We need to build out view models and have data bindings within them. And if you see here, you probably notice that these are all things that you would normally want to have with your main types of connections into your Juice plugin: toggle parameters, sliders, meters, and combo boxes. And all of this then creates a direct communication between Juice and the plugin, so you can manage state back and forth and listen or receive, listen and transmit updates to those states, and then have them show nicely in your UI. To build upon this, you'll want to, for your designer, you'll want to eventually export some definitions so they know how to actually connect them up. And I'll show you how that works here in a second. But what I found, creating a CSV file that you can automate export from your build system or your code, gives a nice foundation so that they can go into Rive and actually hook all those things up. And that kind of looks like this. Essentially, you take a slider parameter, which is a slider view model, and we're going to go through and we're going to get the LFO speed parameter hooked up here. So we're going to create an instance. We're going to then take a view model of plugin controls and nest that under the LFO, nest under the plugin control view model. And then we bind the LFO speed to that. That may sound a little complicated, and it can be, but ultimately, if you go through it a few times, it actually makes a lot of sense and makes the workflow really repeatable as you have lots of parameters. And then ultimately, now that we have an LFO speed slider parameter, we can connect that to whatever we want in our design. And in this case, I've got a slider parameter plugin, which is in the plugin controls LFO speed path. And I've also got a knob map that's converting it from whatever range it's there right now to a normalized value that I can then safely transmit over to Juice. The state machine. So data mining connects the parameters to the visuals, but the real power also then comes into how Rive state machine works. This lets users manage the context and the UI logic without writing extra code. So think about a slider. You don't just want to move the knob. You want to hover state. You want to click state. You maybe even want some animation, depending on how, when you let go of it or anything else. And the state machine handles all that declaratively. So we don't have to hand code different states or introduce, add more complexity to add animation or things like that. The designers can just work with the view models and data binding that we already have set up to experiment and find new ways to build cool interactions. And that's really what makes this really so excited. It isn't just flat things that we're exporting, it's new ways to really encode behavior and interactivity right alongside the design. Now, Rive's great. We just went through that, but let's go move over to Spline. And Spline is cool because it brings in a 3D element to that. You can design knobs, switches, even a whole 3D environment and connect those up to parameters. And here's a screenshot of it. There's a really cool OP1 I found within the community there. We'll talk about the community in a second. And some very impressive things that this product can also do. Similar to how we have our view model data bindings, this actually uses a similar but different approach. It uses a variable system. So we do still declare, in this case, output gain position, so we know where our fader is, if it's a fader for a parameter. We then take that and we bind that to any state or value in the system, and then we can create events. In this case, we have a drag and drop event that grabs a circle and then has a limited range and then sets that variable back. And you can also add formulas in there to, again, get normalized values out of the system as well, if you want to clean it up that way and not do it in your React code. And I think there's also some really other cool things that come through the system because we're not overcomplicating and causing a lot of churn on our C++ side, and we're using a system that's stable and used by, I imagine, thousands and thousands of people already. We have a more stable separation with our view model separation. We also get smaller file sizes out of this. Again, we're not exporting, like bringing Chromium or anything along with this. When we use the Juice Web views, it's just the native OS web technology that's embedded in there. And then we have really small file sizes. If it's a vector, it's probably under a meg. And if it's, rasters and things like that, it does a really good job of keeping things at the right resolution and not bloating your plugin, which you've dealt with, having to deal with resizability and Retina support that can get pretty big. And again, that gives us resolution independent scaling. So your plugin, you now have that built in, and you can work that through your design because the plugin can be aware, or the design can be aware of your artboard size, which is pretty cool. Here's some YouTube links and documentation for all of these. Rive has even a really great AI chatbot that, I've gotten stuck, been able to put my React code in there, and it sorted me out. I think this is all really, kind of accessible to folks. So definitely don't try to get in there. There's a bunch of great videos. There's also excellent communities where people are sharing designs, as some of the ones that I showed already. And there's very active development. Even some of the things that I'm showing here have only really been out for a couple months on the set. So, I also wanted to bring up that there's, I'm showing kind of a main hosting the artboard and giving most of the control to the designer, but there's a lot of flexibility that developers have too in leveraging this, where you can take components and lay them out. So definitely check the documentation to see how you might want to integrate this into your workflow if it's interesting. And so to wrap this up, I'm really excited about a workflow like this. I think it really empowers designers, takes, I think a burden off of developers that I don't think is fair. And I think it potentially gets us to push the boundaries of what UI and user experience can be. Hope to take some time to investigate the tools and see what new experiences you can create. I got my links in here, and you'll be able to see the presentation slides later.
Hey, thank you so much. That was amazing. You finished a little early, so you caught me by surprise. I was just backstage getting the other person set up, but that's fantastic. Thank you so much indeed. Perfect. Well, thank you. And Ryan will be around, I'm sure, in Discord, maybe in Gather afterwards if you have any questions. Yeah. Perfect. Brilliant. Well, I will say thank you very much, and I'm just going to send you to the backstage, and then I'm going to bring up Phil. So our next speaker is Phil Burke, and Phil is just going to join us now. There we are. Hello, Phil. Thank you for joining me on the stage. So Phil Burke is our next speaker. He's going to be talking to us about using Kotlin/Compose multi-platform to revive a historic multiplayer online drum machine. How to write an audio app that runs almost everywhere. So Phil, if you'd like to share your screen again, make sure you share your sound, and
Okay. So I've
over
got
to
my
you
share
when you're ready.
sound on. And there's that. Okay. Are you seeing a slide for?
I'm seeing if you hit the button to start the slideshow. I'm now seeing your slide deck. That's fantastic.
Very good.
Thank you very much.
Okay.
Over to you, Phil. Thank you.
Thank you. Okay. So my name is Phil Burke, and I've been programming music and audio software for a long time, both in game industry, academia, working on experimental music systems, and also working at Google Android on Android Audio. And so I want to talk to you a bit today about using Kotlin Compose multi-platform to sort of restore an old online drum machine. So let me, there we go. Okay, so I'm going to cover what is this app. It was called the Web Drum. And it uses, I'm going to talk about Kotlin Compose as a multi-platform tool. I'm going to move my web camera over, so I'm not looking to the side. I'm also going to talk about a multi-platform audio solution called KC Audio Bridge, and some networking issues, talk about other problems and the solutions I found. And then if there's time, we'll do a little online drum jam at transjam.com. So the web drum is a multiplayer system that allows each green box is a person, and multiple people can be in a room jamming together and sharing a drum pattern. And all of this communication is managed using something called the TransJam server. So there is a central server for brokering all of this communication between the users. This is what the UI looked like in year 2000. Yes, year 2000. So there's sort of multiple tracks. Some are mono tracks for most of the drums, and there's a couple multi-pitch tracks for supporting melody. And you can do things like polyrhythms by having 7 notes in 11 beats or things like that. The timeline for this, the WebDrum first release was in 1997. So this was actually one of the first interactive sort of multiplayer audio programs on the web. The first version was pretty complex with envelope editors. It was a little simplified, easier version was released in the year 2000, presented at ICMC and various conferences. It required a native plugin and in order to do the audio and the synthesis. And this native plugin required releasing 11 versions of this plugin for different browsers, different platforms. So it was a bit of a barrier for people to use it. So we converted to pure Java in 2010, but in 2015, Java applets were removed from the browser. So suddenly the WebDrum did not work, and for the past 10 years, it's been unavailable. But just recently, I converted it to Kotlin and Compose, and so now it runs again on the web, and it also runs on Android and on the desktop. So Kotlin Compose really came to the rescue here. It's a great program by JetBrains. This work in cooperation with Google. The work is done in Android Studio, but it's not specific to Android. You can also just develop for the desktop or for the web. So it allows you to write a program that will run on all of these various systems. The UI part of it is provided by Compose, and it's a kind of functional language that came out of Jetpack Compose that was written for Android, but it works now on all these different platforms. It works really great, but the big problem is there was no cross-platform support for audio, which for most of the people here, that's a bit of a showstopper. So created something called KC Kotlin Compose Audio Bridge, and it's available on GitHub, and I'm sharing that. So the way it's implemented, Kotlin has these expect and actual classes. So it's kind of like a Java interface. So the expect class defines the UI for the class or a function, and then the actual class is the implementation for specific platforms, like on desktop or for WebAssembly. The code is available on GitHub, and you can try it out. There's some demos and some documentation on how to get it to work. The API is very simple, and it's really the lowest common denominator sort of API here. You create an audio bridge, you open it, you get a stereo floating point stream. You can query the sample rate, which is usually 44,100, but might be different for some platforms. And then you launch a job. In this case, it's kind of a coroutine, and you start the audio, and then you render your data into a float array, and you write it and do blocking writes to the audio bridge. If all the data is not written, you can do a little sleep and then try again to write. So that's it. That's basically the API. So it's very simple to use, and and in some cases the implementation was simple, but others not. So this is the implementation for desktop. It uses the JVM, Java Virtual Machine, and we make use of the Java Sound API. So this was pretty simple. We just convert the float array to a short array and then to a byte array and then output it through Java Sound. On Android, it was also pretty straightforward. The Android audio track has a method that you can write, which is a floating point array. And it takes sample offsets instead of frames, so you just have to convert from frames to samples. Actually, you don't. The audio bridge takes care of this. So that's the implementation, most of the implementation for the Android part. The web part was a lot trickier. I wanted to use web audio for its good low latency and performance, but the realm and the thread in which the audio workload node is working is very restricted, and you can't just communicate with it directly like you can, with the Java Sound implementation. And so the way to get around this was by communicating to this restricted domain through a FIFO. So the audio data is written through a FIFO. The FIFO is an atomic FIFO, which for audio developers, if you don't know, it is a very, very helpful design pattern. Basically, each thread can control one cursor into the data. So the application is writing data, and it is the only thread that updates this frames written. And the audio workload node is reading the data, and it updates the cursor for the frames read. And they can both read both cursors, so they know when and where to read and write. So WebAssembly has a mechanism for sharing data between threads, and it's called a shared array buffer. And it's a critical data structure for doing this. So we use a float, and you can wrap it in like a float array or an int array. So we use a float array for the audio PCM data, and then an int array to contain the read and write cursors, the buffer capacity, underflow count, things like that. Now, in order to access these, you need to use the Java Sound atomic functions so that you get the proper flushing from the cache and the memory barriers and so on, so that these different processes can see each other. So we're doing an atomics load to get basically the frames read, so we know this is the callback, so it knows where it read the last time, and it converts that to an index into the float array, reads the data, and then it updates the data in the for the frames read. In order to do this, there's so much security in the browser, which is an unfortunate necessity. But one of the things you'll have to do to enable this is to provide a .htaccess file in the folder that contains your your applet. And I include one in the KC Audio Bridge. It's an invisible file, so it's easy to miss if you just drag the files over from the Finder. But this enables this cross-origin capability, and it magically enables the shared array buffer. Future for KC Audio Bridge, this is an experimental API, and it may change. There is we may also look at adding native desktop support using port audio, that which would give it a little better performance and make it not require a Java virtual machine for desktop applications. The iOS support will be nice. I'm not very familiar with iOS coming from Android, but maybe someone could look at the GitHub repository and volunteer to help support that. Audio input, it'd be nice to have, but there's so many security issues around audio input that it would have just complicated things. So it does not currently support that, but maybe in the future. So other changes were also needed to get to convert this old Java applet to a Kotlin Compose multi-platform applet. And one of the things that's very different in this new environment is that you can't just use regular threads. You have to use coroutines, which is kind of a cooperative multitasking system, and you have to be a little bit more deliberate about creating these threads. And so you're constantly going in and out of these functions, and you can't just go into a thread and sit there because it might block the UI or it might block some other coroutine. So because you're going in and out of these functions, it's much easier to implement them as a state machine. This is also another design pattern that can be very helpful for real-time audio or interactive audio, where you may have a lot of information that you're keeping track of, but you can encode that as a single state variable, and then you just transition around these states by updating the state variable, and then maybe using a switch statement to process differently based on the state variable. And then there's communication between these state machines. So data may come in from the network client using the Kotlin Compose state flow, which is a kind of way for data to flow from other coroutines up to the UI, or in this case to the state machine, and then there are callbacks from the network state machine up to the UI state machine. So the UI may be switching screens from a login screen to the drum screen, and the network state machine is busy trying to set up various rooms or broker communication between the applets. So these separate state machines can communicate. And then there's another coroutine that's actually doing the sequencing and the drum audio synthesis. So another difference is that the original WebDrum used JSyn for instruments, which is a Java synthesizer that was written also back in the 90s. And it's because it's Java, it won't get converted to to the WebAssembly. The Kotlin can target all these various WebAssembly or native code or Java bytecode, but it has to be Kotlin. And so what I did is I took the JSyn Java code, generated the sounds, generated samples of those sounds, and then the Kotlin code is just playing back those original JSyn samples. So the sounds are the same, they're just not being generated on the fly. I'm actually thinking about converting JSyn to KSyn, and since most of it is math and DSP, it should convert pretty simply, and then I would be able to use the synthesis code in a variety of multi-platform applications. The network connection is obviously required for this multiplayer code, and I used KTOR to implement a TCP/IP connection to the Transjam server. That worked great on Android and on desktop, but on the web, again, things were different. So I had to use a WebSocket. So KTOR supports a WebSocket implementation both as a client and a server. So I wrote a very simple relay that runs on the same server as the Transjam TCP/IP server, and it just relays messages coming in from the WebSocket, and it sends them to the TCP over TCP/IP to the server, and vice versa. So it's just a classic relay. It doesn't really do any processing. It's just sitting in the middle and passing messages back and forth, and that works. That seemed to work pretty well. Regular Java exceptions don't work, so you just have to sort of rewrite your own class of exceptions for your own custom IO exceptions and so on. I was able to come up with something that looks a lot like the original WebDrum. So this is version 3, and my goal was to recreate the original WebDrum. I did make a few small changes. I moved the sort of global controls like the tempo control and the loudness controls, things like that, up to the top. And that allowed me to have the bottom part be scrollable and to integrate it with a chat message. In version 4 of the WebDrum, I'll probably rethink the UI and maybe use a more modern approach for the UI. But my goal in this case was actually to kind of recreate the original WebDrum, but in this using modern technology so that it could run on multiple platforms. The line count, the Kotlin code is a bit smaller than the Java code, but that may be because I converted the Java instruments to just playing samples. So there was a lot of Java instruments that were not in the Kotlin code. So to conclude, how are we doing on time? I think I'm pretty good on time. So to conclude, I find that using Kotlin Compose is great for generating portable audio and music apps that run on Android. It supposedly can target iOS, desktop applications. There was really very little that had to change. Just this backend audio connection. And the KC Audio Bridge handles that for most applications if they just have to output audio. So please contribute if you can, not money, just expertise. Take a look at the KC Audio Bridge, try it out. Maybe we can make improvements there. And if there's time, I would like to invite people to join a small jam at this link. So it's at transjam.com. And I'll go there. I think I'm still, this is still being broadcast. So if you go to transjam.com, you'll see this link. There's links to the slides, GitHub. I'm going to run the WebDrum app. I'll run this one. I'll put in my name, Phil. Okay, there's no existing room, so I'm going to create a room. And this it's a typical drum pattern, but if you, okay, another user has arrived, great. So I can actually chat and send messages to people. See Javier has joined. There may be multiple rooms if more than, I think there's a maximum of maybe 6 or 8 people in a room. So if one room's full, just create a new room. And so if you need to click this little own button here, that allows you to control that drum. Once you click it, then you can go in and start, filling in some of these different sounds. So I may change my timbale here to a zoop sound. And it can also convert this to a Chebyshev polynomial sound. So you can type, device to others. control a track, or you can map out a strategy like, oh, let's speed up, let's slow down. Why don't you, try this, or let's try polyrhythms, things like that. And turn this down just a little bit. So I found that the chat part of it was, I think, a really important part of the white drum, because it helps people realize that they're not just interacting with the bot, that they're actually jamming with other people. I heard a chime. That might mean that our time is up. But thank you for listening, and I'll be sticking around for a while. And
Phil, you've still
go to the
got
Q&A.
5 minutes. Still got 5 minutes if you like, Phil.
Oh, okay. So should I? I'm going to just mute a bit of that. So should I go to a Q&A, or?
Do whatever you like. I just meant if you had more to speak on, you still do technically have 5 minutes left. The chime was just a warning to let people know in 5 minutes the closing address is starting. So
okay. Well, I guess I when I was timing it, I maybe I wasn't quite as nervous because I was much slower, so I got through a lot shorter time.
No, that's
just I'll point out some things about the interface here. So you can do things like have 16 notes in say 8 beats, and you'll notice that this now is a shorter row. So then that lets you do faster faster beats, or I could maybe do like 12 notes in 8 beats, and then I can kind of do various polyrhythms. There's left-right panning and stuff you can do, obviously. These will let you select various instruments. Ring mod bell is so there's FM bells, ring mod bells, a plucked gong, claps, which is a stochastically generated clap sound. So lots of different options there. This fader here is a yes/no fader, and I'll let you can experiment with that and kind of find what that does. You might be able to imagine what it does, and you may be right. Also, there's a solo button, so if you want to just listen to what you're generating, you can solo that. That will not affect what other people hear. It just allows you to do a sanity check on like what your tracks are doing, or you can also solo other people's tracks. So that's the basic UI, when you can hide the chat or not. And this looks very similar on Android, except that the chat covers a bigger area of the screen and it's scrollable. So that's one of the major differences. Oh, also you can change the tempo. I can slow it down, and I can change, to a 5-tone just intonation tuning system if that's your thing. We can change the bass, the fundamental for that. Well, these over here are loudness controls, so you can make a very loud or very soft sounds. I'm going to depart this room. Thank you, Rocco. And I can see that they're okay. Yeah. So at the moment, the people are in the bonkers room. So, but you can come in and move between rooms. So I think maybe we can move to Q&A, Jim, I think.
Hey, Phil. Yes, perfect. Thank you very much. What a wonderful talk to round everything up. I want to pause pause your music. Brilliant. Thank you very much indeed, Phil. That was amazing. If you would like to speak with Phil about anything you've heard, head over to Gather after the closing address and engage with him there in Gather, or post your questions in the Discord and he can get back to you there as well. So we'll say thank you very much to Phil for being our closing talk of the conference. And well, thank you very much, Phil. And I'm going to send you into the backstage. We're going to move to our closing address. So, for our penultimate session, it is now, well, penultimate, our last thing of the stream. You can tell I've been in Zoom for 9 hours. And it is Tom and Bobby from the ADC 25 conference to talk to us. Over to you, Tom and Bobby.
Hi, everyone. Hope everybody had fun today.
Yeah,
Tom's going to kick us off with a little closing remarks, and I'll jump in. So thanks for hanging out today. And yeah, looking forward to hear what everyone thought.
All right, I think we are ready to go. So, hello, everybody. I hope everyone has had fun today, and anyone who's been with us from the beginning still has a bit of energy left. If you thought a talk was particularly good, a poster was interesting, if you went to one of the community meetups, if you did the treasure hunt, if you spoke to someone new and made a new connection, or spoke to someone old, a friend you've not seen for a long time, or in fact, one you've just seen last week, please tell someone about it. Post about it on social media. Telling people about ADC is a very easy way to support the conference, and it really does make a difference. So please share any of your experiences from today. Speaking of ways of supporting the conference, ADC would not be possible without the support of our sponsors. ADC doesn't make any money, but even if it did, it's run as a non-profit event. So any support from sponsors or ticket sales goes directly into making the conference better for the audio developer community. So the first of a fair number of thank yous I'm going to run through now, and probably the biggest thank you goes to the companies that have given this community their support. The second biggest thank you goes to our speakers and the leaders of any of our community meetups. It probably goes without saying that as well as sponsors, you also cannot put on a good conference without a compelling program. And we are fortunate and delighted that there is so much desire from our speakers to share their ideas and work and allow other people to learn from what they've done. We also need to thank our array of volunteers who've been helping people today in both Gather and on Discord, and thank a whole load of people who are much less visible but are nonetheless essential. The ADC team, alongside Digital Medium, who provide most of our online services and recording, have been working really quite tirelessly for the past few weeks to put all of this together. And I hope it has been a real success. Because that was one of the main motivations for putting on this free event today. It is it's difficult to describe how a conference on our online platform Gather works, but if people can come to a free event like this and actually experience the world that we have created within Gather, then they can help us communicate that experience to their friends and colleagues. And we can widen our audience by bringing many more people into the conference community. If you haven't explored Gather today, then you have likely missed out on quite a lot of things that have been going on. So inside this virtual environment, we have recreated several parts of Bristol where the main in-person ADC conference is being held in November. More on that in a second. And you can move through this virtual spaces and meet and network with people there. All of the community meetups today were in Gather. The poster sessions were in there too. There was even a treasure hunt. And perhaps most importantly, there is a quiz happening in Gather immediately after we finish speaking here. So please hop straight over to that when this session wraps up. The online version of the conference is really important to us as it allows much more of the community to participate. There are loads of people who cannot make the journey to Bristol in November for the in-person component of the conference. And the online community is much more diverse and arguably much more fun. So why join us again in November? Well, it will be a lot like today, but with more of everything and some additional things on top of that. With a longer event and much more people, there will be much more networking. This year, we had an unprecedented number of talk proposals, really far more than any previous years. And the task, and the normally difficult task of selecting the program was even more difficult when there were so many good submissions to choose from. Even selecting talks to fill 3 whole days was difficult. And like, sadly, really many great sounding ones didn't make the cut. So the program this year is super strong. And with all those extra talks, we also have 8 workshops running on the first day in parallel to a whole series of talks with a similar format as today. The sponsors will all be exhibiting, both in person and online. And this is a really great opportunity to talk to them and find out what they're doing. Maybe have a play with their latest and greatest hardware and software. If you're looking to find a job, a lot of them are sponsoring because they are recruiting. Speaking and interacting to them really is going to be fruitful for a lot of people. And there will be installations, performances, social events, and more.
And Tom, I wanted to throw in, we had so many proposals this year for game audio talks that we were able to create a game audio track on one of the days as well. It was worth mentioning. First time doing that. It's our 10th anniversary conference and we have a game audio track, so that's lovely.
Yeah, and if all of that sounds appealing, then if you purchase your tickets today, then you can use the discount code ADC25_quiz hunt to get 20% off the price of an online ticket to the main ADC 25 conference in Bristol. You can do this by going to the website audio.dev, where you can put that discount code in before you purchase your tickets. You'll work it out. Also, the website is the place to go to find out any other information about the conference. You will find things like the schedule, travel and accommodation, though if you're attending online, this hopefully isn't very problematic. Ticketing, code of conduct, links to videos of talks, a jobs board, and more. However, if you want to be kept informed about upcoming events and up to speed about everything else that we're doing, then subscribing to our newsletter is the best way to do this. The mailing list is relatively low volume. We're not going to flood your inbox, but you will be amongst the first to know about what we're up to. One of the things we're up to is our diversity scholarships, which are still available. If you think that your presence at the conference would help us to make the conference going community more diverse, then please go to the website and complete the application form. Our diversity scholarships are made possible by our diversity scholarship sponsors, who are ADCx, Focusrite, Pace Anti-Piracy, Roland, Ableton, Dreamtonics, Audiotonics, and Steinberg. And they have all very generously provided funding to cover free tickets to the in-person event. ADCx in particular has been particularly generous, and they are also providing hotel accommodation for the 3 nights for 10 of the successful diversity scholarship applicants. So please take advantage of this wonderful opportunity. Something else to take advantage of is the ADC mentorship program. This is something that we run, and it is completely free, and you don't need to have attended an ADC event to be part of it. The 2025 program is already underway, and we have around 230 mentors and mentees enrolled. For mentees, this is fairly obviously an absolutely amazing opportunity to get guidance and advice from someone with more experience within the community. And a mentee needn't be someone who is just starting out. We will also look to help people moving into the industry or even just contemplating a change of role within the industry. For mentors, we have heard a great talk by Jorge Garcia today on why you should become one. But I would like to add that we always have a much larger number of mentees than mentors. So any additional mentors that we can bring in would really help us. If you do join as a mentor, it's a really easy way to have a really huge impact. Really just a small amount of your time can be extremely valuable to your mentees and make a really huge difference. So it's really it's a really effective way of giving something back to the community. We will be opening the 2026 program in spring 2026. Again, subscribe to the ADC newsletter if you want to be kept up with the latest news. And that is about it from me, but today is not done yet. So straight after this session in Gather, we have the ADC Gather quiz, which is in the chuck boat at the bottom of the Bristol Harbourside in Gather. You'll be put into teams, or you can self-organize. You'll work together, answer questions, have some fun. You know how it's going to work. Otherwise, now it's just a final thank you to everyone here for attending and being part of today. And I guess I'll hand off to Bobby, who probably like to wrap things up.
I'll keep it short and sweet. I think, Tom, you've basically caught all the important thank yous. A lot of people involved, and another shout out to the speakers. Thanks for making time for this. If you missed a talk today, you still can go back to the stream on YouTube. Just you can do a little video on demand there and just punch along the timeline and see some talks you may have missed. Eventually, these talks will be kind of cleaned up and posted into the Audio DevCon channel on YouTube. So if you haven't subscribed, please subscribe, and you can get alerts when those new ones are posted, which is great. I did want to give a very special thanks to Jim Roper and Jonathan Roper. Jim, you've been an amazing host today, and a lot of this tech is not possible without the work that you and your brother Jonathan do. So thank you for your tireless efforts in making this a very special place. You know, online conferences can be sometimes a bit of a Zoom webinar only with nothing else. And I think what's been created here with the interactivity is just incredibly special. So thank you to Digital Medium, who is Jim and Jonathan Roper, and a shout out to Ralph, who's our in-house designer and graphics artist that helped a lot with what you see in the backgrounds and in the waterfront and what you're about to experience now in the quiz hunt. So I'll keep it short. I hope to see many of you at ADC 25 Bristol, November 10th through the 12th. And with that, good luck on the quiz. Yeah.